is mean? What is mean as a measure of, what is mean as what? As a measure of central tendency. Okay, what is mean as a measure of central tendency? Yes. Yeah, what is mean as a measure of central tendency? What is, when you talk of a mean, what is it? Hello, are you there?
Yes, doctor.
What is
The
mean?
the mean the
Yes,
mean
please let me
is
hear you.
the average, taking the average of items or a list of items.
Okay, all right. So mean is what I want to bring Sigma symbol. Okay, so symbol. Okay, great. I've gotten it. So that's fine. So when we talk of what mean, when we talk of mean, is the word, is the average. But what is average? When you say average of something, what does it mean? When you say average of something, what does it mean? Yes. What does it mean? When you say average of something, what does it mean? What, I don't understand the meaning of average. Yes. What does it mean?
Okay, okay, look,
Yes.
yes, please, when we talk about the average, it means that we should add the total number of values, and then we should add the values and divide it by the total number.
Okay, good. So which means that more or less the sum over the word, over the total. Is that not it? So so when you talk of the mean is basically the word, the sum. Okay, so that's a sum over the word. So you can talk of the sum of the word of the data. Okay, so sum of the data divided by the word, by the total number of data. Okay, so here, one thing you should know is that you can only do, mean can only be calculated. Don't forget this one that I'm going to talk about. Mean can only be calculated for what? For interval ratio, just to continue. So mean can only be computed for interval ratio data. Okay, interval ratio data or continuous. Okay, continuous data. All right, good. So mean can only be what? Computed for interval ratio data. So anything apart from that, you can't use word. So cannot, okay, you cannot word, cannot be computed on word categorical data. All right, so cannot be computed for categorical data. Okay, good. So it should be what? It should be only continuous word data or interval ratio data. Okay, great. So it can't be computed for categorical data like sex, color, sex, color, shape. No, you can't calculate. You can't calculate mean. Okay, for categorical data. That is of. It can only be calculated for continuous data. Okay. All right. Good. And there's another thing that we use mean. We use mean when the data is what is almost what so mean is usually what usually preferred when the data set is following normal distribution. Okay, like almost, okay, like normal distribution, okay, like that. So almost following normal word, following normal following the normal distribution. Okay, and when you talk of the normal distribution, when the graph is almost symmetrical, okay, when the graph is almost symmetrical, okay, good. So that is a when the distribution, when the distribution is what almost symmetrical, okay, it's symmetrical, or okay, so it's symmetrical or almost symmetrical. Good. So when we have the word, when the distribution is symmetrical, almost symmetrical, that is when we use the word. We use the normal distribution. Okay, that is where we use the normal distribution. Okay, and then on top of that, okay, remember when the data is skewed. In fact, when the data is skewed, okay, the best one, you know, every time when the data is skewed, we hardly report mean. Okay, when the data is skewed, we prefer the median. Okay, so anytime the data is skewed, okay, is skewed, the median is more preferable. All right, so when we have the word, when we have our data skewed, okay, we rather prefer the median to the mean, okay, when we have skewed data, okay, when the data is skewed, we'll rather report the median, okay, as a central tendency rather than the mean. So when the data is almost perfect, so when we talk of when the data is almost perfect, when the data is almost perfect, we are talking about what? We are talking about, let me draw so that you have a rough idea what I'm talking about. So when the data is almost perfect, so we are talking about something like this. That's a normal distribution data, and it goes this way. Something like this, okay? So something like this. All right, so when we have the normal distribution, okay, so the normal distribution data like that, okay, we normally prefer to report the mean, okay, the most preferable one is the mean, okay, but when it is skewed, whether positively skewed or negatively skewed, we prefer to report the median rather than the mean. Okay, good. And then one thing about this data, okay, is that it is what it is sensitive. Okay, one thing about this data is that about the mean is that mean is what is sensitive to outliers. Okay, outliers like extreme value mean that extreme, I think I've talked about this before, extreme values. Okay, so mean is what is sensitive to extreme values. So when we talk of extreme value, like the analogy that I gave, that in children's party, you were told to take all the ages of people who came for the party. And then after that, when you calculated the mean, you realize that the mean is what? The mean is 28. Or the mean is 28. So you could see that grandpa and grandmom brought their grandkids, and they stayed and they collected their ages as well. And so anytime you include those extreme values, okay, they tend to affect, okay, they tend to affect the mean significantly. So mean is very sensitive to outliers, unlike the mode and the median that are for even the mode is not even affected by outliers, And as for the median, it's slightly, okay, it's slightly, it's not really affected by outliers that much, okay. But the median is extremely sensitive to outliers, okay, extreme values. And so anytime and we have what extreme values, okay, we rather prefer to report the median rather than the mean. Okay, all right, good. So now that we have the overview about the median, okay, about the mean, what we're going to do is that we are going to talk a little bit about the calculation aspect, which I'm expecting that we should be able to go through it quickly. Okay, so when it comes to the mean, okay, the mean, so mean calculation. All right, so mean calculation, okay, so mean calculation. All right, so let's see. So we'll go first with the word, with just a simple listing. Okay, with just a simple listing. All right, so let's see. Okay, so let's say I have 2, 4, 6, 8, 10. Okay, and then see. All right, like that. Okay, and then the fact to calculate the mean. Okay, so in this particular calculation, that is going to be what? So the mean. Let's see whether I can get a symbol of the mean. Let me see. I can get a symbol of the mean online. Let's see. Okay, so mean symbol. Okay. All right. So we've gotten the mean symbol here. Okay. So here, so mean is equal to what? It's equal to the sum over what? Over total. Okay. And so let's see the mathematical. So let's see. Okay, so let me put mean here, then go and write the mathematical aspect. So that's going to be this is equal to sigma. Let me get a sigma symbol online. Sigma symbol. Okay, so sigma here. Okay, so like that. So sigma s. Okay, all over what? All over. So let's see. So sigma x all over. Okay. All over n. Okay, all right. So x over n, or simply, do you know what? Let me make it this one. Let me make life easy for ourselves. Okay, so sigma x over y over n. Okay, so the sum of y, the sum of y x over n. Okay, so sigma x. So this the sum is this, and then n is the total. So in this particular case, when we are calculating the mean, it's going to be what? So the mean. Okay, so when we are calculating the mean will be what? 2 plus what? Plus 4 plus 6 plus 8 plus 10. Okay, then you count them 1, 2, 3, 4, 5. So the n is equal to what? So all this one divided by
5.
So it is
5.
So let me put underline here. And all this one divided by what? 5. Okay. And this one will be equal to what? Will be equal to
30.
equal to will be equal to 30 divided
Divided by
5.
5.
5 and that will give us what? That will be equal to what? 6. Okay, that will be equal to 6. All right, great. That will be equal to 6. Any headache so far? Any headache so far? Okay, so let me give you another example for you to try your hands on. Let me give you another example for you to try your hands on.
Hello.
Yep, go ahead.
Yeah, Doc, please, I just want to ask, like the mean, when you ask of the meaning of the mean, we said is the sum of the data over the total number of data. So is that the best way to explain it to a layman?
What
To
is the
explain
best
the
way?
meaning?
What is the best way you explain it to a layman? If you have something in mind, then let us know.
I mean, I don't know what it's like. For example, when they say the mean age of a class, then my understanding is that when you take the total number of ages in a class, you sum them up, you divide it. The value you get, that is the least age. So
Mean,
to me, my understanding would be
mean
the
doesn't
least
mean
possible.
list. Mean doesn't mean list. Mean is the average of the class. So basically, the sum divided by the total. So the sum of divided by total. That is the best definition. That's the simplest way you can tell a layman and you will understand. Okay, that's the best. That's why I say if you have something in mind, let us know.
Okay. Yeah.
So let's say do this one for me, 12, 18, 20. Okay, so let me see. 1, 2, 3, 4, 5. Let's say 16. Let's say 24. 1, 2, 3, 4, 5, 6, 7. And let me add last one. Let's say 14. So find the mean. Find the mean of these values. Find the mean of these values. Find the mean of the values. Okay, please, what is the answer?
I got 12.75.
Okay, so let's see. So our mean is equal to the sum of the sum over the word, over the total. So which means that our mean here is equal to 10. Okay, so 10 plus 8 plus 12 plus 18
Please,
plus
sir. So I had a 15.25.
okay, we are doing it together.
Okay.
16 plus 14. Okay, all right, all divided by, so you count 1, 2, 3, 4, 5, 6, 7, 8. So n is equal to 8, all divided by 8. So when we add everything, what are we going to get?
It's 15, yeah.
When we add everything, please, what are we going to get?
15.25.
So when we add
You get
everything,
122.
okay, so
122.
so the sigma s is equal to what? 100 and what?
122.
22. Okay, and then our n is equal to 8. And so our value is going to be what? Our value is going to, so mean, or mean, okay, all right. Our mean is equal to what? 122 divided by 8. And that will give us what? Please, okay, let me take my calculator. Let me use calculator online. So 122 divided by 8. Okay, I had 15.25.
Yes.
Is that what you had?
Yes, sir.
Yes.
Yes, sir.
Any different answer? Any different answer? Okay, this one is quite straightforward. Okay, this one is quite straightforward. Okay, great. So let's take it this way that okay, so the mean of so calculate the mean weight, the mean weight of 10 men in 10 men, okay, 10 men, and then you've been given the data, let's say 60, 58, 51, okay, 79, 80, okay, 81, 82, okay, 78, 65, 55, so 1, 2, 3, 4, 5, 6, 7, 8, 9. Then 100. Okay, so right, in kilogram. Okay, good. So then they ask you to find the word, find the mean. Okay, so I've talked about calculate the mean word, the mean weight, okay, of 10 men. Okay. Okay. Our brother had what? Our brother said that his mean is his mean is equal to what? 70.8 kg. Okay, any different answer? Any different answer from what our brother had? Yes, any different answer? Any different answer from what our brother had? Yes. Any different answer? Yes. Any different answer? Mm-hmm. Is it the same for all of them?
Yes, sir.
That's 70.8.
Okay, then that is fine. Okay, good. So okay, so when they give it to us this way, so you see that these calculations that we've made, okay, let's say when we are dealing with, let's say, population, all right, population, they give us maybe list of mean and then everybody included. That is very wide. That is quite easy. Okay, all right. So we'll do another calculation for maybe so these are basically listing method, then they will ask you to find the mean. Okay, all right, good. Maybe let's do one last one. Let's take it this way that you do what measurements. Okay, so measurements of what? Measurement, let's say for the sake of physics people, measurement of word of let me say veneer. Okay, the veneer word, veneer measurement. Okay, so let's take it this way. You use micrometer screw gauge, and then after you measure something, you had what? You had 0.5. Okay, so let's say in words. So let's say this one is in centimeters. Let's say in millimeters. Okay, so 0.5 millimeters. Another one 0.25. Another one 0.75. Okay, another one 0.35. Another one 0.46. Another one 0.54, like that. So 1, 2, 3, 4, 5, 6. Okay. All right. So let me even just make it 5. Okay. Let me take this one out. Okay. Let me keep them. All right. Great. So like that, and then they ask you to find the word. Find the mean of the measurement. Okay. Yeah. It's what are you going to get? What are you going to get?
So you will get 0.475.
Okay, so our sister is saying we'll get what?
475
0.475.
mm.
Okay, millimeter. Any different answer to this effect? Any different answer to this effect? Any different answer to this effect? Any different answer? Yes. Is that correct for everybody? So you add everything here. Please, exams, make sure you.
That is correct.
Okay, that's correct. Okay, please, Ezra, make sure you go with calculators. Please, make sure you go with calculators. Okay, all right, great. So that is that. Okay, for this particular one. So calculation of a mean is easy. Okay, now let's see what if I give you mean with what? The table. Okay, with mean with table. Okay, okay. So mean with table. Okay, so let's see mean with table, and then I give you this one. So mean with table, let's say I come here, I want, so in this case, I want 1 to 5 columns, okay, and I want, okay, let's say I want rows to be, okay, let me make my rows 5. So here should be maybe 4, and then that, okay, 1, 2, okay, this. All right, like that. So now I have something like this, okay? And then, so let's say this is my topic, let's say age, and then frequency, okay, frequency, like that, okay, great. And then, okay, so let me do this one, okay, great. Okay, so let's say I have something like that. Then let's say age, 1, 2, 3, 4, 5, 6. Okay. All right. So let me put this one, copy, paste. Okay. So let's take it this way that this is the children ages of what? So ages of children at a party. Okay, so here, let's say 1-year-old people were 2, this one were 5, this one were 6, some were 8. Okay. This one were 2, and this one were 4. Okay, wait, let's see. When you put everything, what are you going to get here? There is, when you total everything, what are you going to get? When you add everything?
Like 27 or so.
27.
27.
Okay, so let's make this one. Let's make this one. I want it to be 30. So let's make this one 6. And let's make this one 3. Okay, great. So let's say we have something, we've been given something like this. So this is still not, it's not a group data, okay, because what is here, they are not in groups, they are not in categories, so they are not in groups. So like that. So our age, remember age is represented with what? With X. And then the frequency is represented with what? F. So something like this, what do? We've been given something like that, and then we've been asked to find a word. So let's take it this way, that we've been asked to find the so let me duplicate this, copy and paste. So yeah, we've been given this. Okay, let me this one go up. So we've been given this. Okay, so children at a party, and then we've been given this figure here, and then we've been asked to find a word. We've been asked to find the mean. Okay, for children at a party. We've been asked to find the mean. Okay, for children at a party. All right, great. So in this case, what are we going to do? What are we going to do?
Yes. Hello.
Yes. Hello.
Yeah. With this, what we are going to do is we take the x value times the f value. That's the age times the frequency.
Okay, good. Beautiful.
Each of so we have 1 times 2.
Okay. All right. So here, okay, you are right. Okay. But so here, our mean calculation goes this way. Let me take my symbol here. Okay. So our mean calculation goes like this. So for this table form of data, we have, instead of just sigma x, then we use just sigma x over n when we are doing the listing method like the way I've done here. Okay. This one like that. When we are doing the listing method, this is the one we use. Okay, this one. But when it comes to the table one, we'll do what? We'll do sigma fx over sigma what? Over sigma f. Okay, great. So we have the sigma f is the what? The sum of the whole frequencies, and then sigma fx is when you multiply this by that. Okay, so let's see what we're gonna do to get our value. Okay, so in this table, okay, in this table here, we'll calculate for what? Our fx. So fx is basically the age is x and frequency is f, and then we'll do what? We are going to multiply this by this, and then we'll put it here. So this by this will give us 2. This by this will give us 10. This by this will give us 18. This by this will give us 32. This by this is 30. And this 4 by what? 4 by 3 is what? It's 6 by 3 is what? 18 as well, like that. So when we finish, what are we going to do? Then we need what? We need to find our sigma what? Sigma s. We need to find the sigma s. Okay, so let's see whether we can split this into 2. We need to find our sigma. This is split. Okay, so the column now wants the row. Okay, so this one into 2 rather. Okay, great. So here we are going to find our what? Our sigma. So this side we want to find our sigma f. Okay, our sigma f. Okay, copy this our sigma f. Okay, and this side is our what? Sigma fx. Okay, so what is our sigma f? Okay, when you add everything here, okay.
30.
What is our sigma f? Yes,
30.
It's 30. Okay, and sigma fx, yes,
102.
102. Okay, great. All right, so so in this case, we want to find our mean. Our mean is equal to what? Our mean is equal to um, uh,
2, 10, 18,
So
32.
please, it's not 102, it's 110, right?
It's 110, Doc.
it's 110.
The
It's
FX.
110.
Okay, good. 110, good. Why is it when I paste this somewhere here, it's not coming? I don't know why. Why is this somewhere not coming? Let's see. I don't know. Okay, so let's see. Okay, so we have the word. So we have the let's see this. Okay, let's see that. Okay, great. It's not coming. All right, great. So with this, we're now going to compute our mean. So our mean is equal to what? Our mean is equal to sigma fx over sigma f. So that will give us 1, 1, 0 divided by what? 30. Okay, and that will give us what? Please, what is the answer?
3.67.
3.67. Okay, all right, great. Okay, so that is the answer. Please, are we clear with that? Are we clear with that, please? Hello, are we clear with that? Before I give you another example,
Yes, sir.
are we clear with this one? Are you sure? Okay, so let me give you another example for you to try your hands on. Okay, great. So let me duplicate my slide here. Let's see. Okay, great. Okay, so let's see this one. So okay, let's see like that. Okay, so let's take it this way that I want to make your head spin small. Okay, so instead of giving you, so this is let's say age of what of you can say ages of children at a playing ground. Okay, so let's see. I'm going to give you that. So here you are going to do tally. Okay, so 1. Okay, so 3, 5, 6, 6, 1. Okay, 3, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9. 4, 1, 4, 3, 2, 1, 6, 5, 1, 2, 3, 4, 5, 6, 7, 8, 6, 3, 4, 4, 2, 1, 6, 4, 5, 6, 4, 3, 3, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. The next one, 1, okay, 4, 4, 3, 4, 5, 4, okay, 3, 4, 2, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, great. Something like this. So I've given you this one. So you are going to, my first question goes this way. You are going to find, so my question goes, find, okay, so draw, okay, so construct a frequency distribution, okay, distribution table for the ages of the kids, of the children. Then B, find the mother age. C, find the median age. D, find the mean age. All right, start with. So here, remember there will be what? In this case, there will be tally. Okay, so you have tally because of the way the data has been given.
Sir, please, the CND, you have written mean age for CND.
This one should be mean. This should be median. Okay, great. So take this one here. Okay, so here there is going to be tally in it. All right, so start work. So you have roughly 6 minutes to, okay, let me give you, realistically, you should finish this one within 7 minutes. So let me give you, yeah, 8 minutes, we should be done with all of them. Okay, so start work. Okay, great.
No, please, is it just one data or it is made up of 1, 2, 3, 4 data?
These are all the data that we have. They are 40. 1, 2, 3. There are 40 individuals, 40 kids. So you are going to use it for tally. So you do tally. 1, 2, 3, 4, 5, 6, 7, 8, 10. 1, 2.
Doc, please, for the B, is it a model age or model age?
Mother. All right, start work.
doctor.
Yes.
And I have my answer.
Okay, so let's wait slightly. Okay, 3 more minutes, and then when we have a couple of people, so that we want people to try their hands on, and then, okay, so,
Thank you.
okay, great. Okay, great. Now let's do so let's see our frequency. Yes.
Does the
Yes.
frequency is 1,
Yes.
2, 3, 4, 5, and 6?
Okay, so let's see. Okay, so you have to, you see when they give a table like that. So here number 1 is what? 1 is what?
1 is 6.
F.
1 is 6.
Okay.
6.
2 is what?
5.
5.
5, 3,
8.
8, 4,
11.
11. Oh wow. 5,
4.
4, and then 6.
6.
Okay, great. So here, so you know that once they give it to you this way, you have to do tally. So I can't do the tally, okay, so because they are good. And then from there, so our sigma what? Our sigma fx. Our sigma fx. Our sigma fx.
6.
Okay. Here is 40. Okay, and then let's see the top here. Yes, fx is what?
6.
So here is 6.
10,
10,
24,
24,
44,
20,
10,
36.
36,
So when you add everything, what are you going to get? 139 or
140.
140.
you're going to get 140.
Yeah.
140.
Oh, okay.
Yes.
140. Great.
Baba,
Okay.
Baba.
That is 140.
It's 140, sorry.
Yes, 140.
All right. So 140. Good. Okay. And then we are going to find our way. We are going to, so here, this one here. So let's see the first one here. The modal. So this is the frequency table will score you. So what is the modal age? So modal age is what? Obviously is what? 4
Yeah,
years.
the middle age is 4.
Yes.
4 years.
4 years. What is the median age?
The middle age I had 4.
4
You had
years.
what?
4,
Okay.
4.
4 years.
Okay, so the median, the number is what? You can see that this is even. So even means that you add 1 to it. So you go for what? You go for median position is equal to what? That's a sigma.
F
Let's see. Okay, so let me see sigma. Oh, okay.
plus
So
1.
so sigma f plus 1. Okay, divided by what? Divided by 2. Divided by 2. And that will give us what? That will give us 41 over 2, which will give you 21 point what? To
Oh,
give us
20.5.
20.5.
20.5.
Yep. So when you add this plus this, so when you trace it, you add 6 plus what? Plus 10. Okay. That will give us what? No, 6 plus 5. Sorry, 6 plus 5. That will give us 11 plus what? 8. That will give us what? That will give us 19. Right? So you can see that clearly that the number will be here, will be inside the what? Will be inside the 4. Okay. All right. Great. So from the table, okay, the median age equals to what? 4 years. So it will be within here. It will be within here. All right, great. And then we want to find our what? We are going to find our mean. Our mean is equal to what? Our mean is equal to sigma. Our mean
Sigma
is equal to
fx
what? Our mean is equal. Okay, sigma fx.
over
Okay.
sigma f.
So our mean is equal to sigma fx over what? So
Sigma
fx over sigma f. Sigma f. Okay. Over sigma f. And this one will give us what? That will give us
140
divided by 40. And this is equal to
3.5.
3.5
3.5 years.
years.
All right, great. Well done. Okay, so we want to do another one with what? With group data. Okay, so when they give us group data.
Please, I have a question.
Please go ahead.
You said the median age is 4, and I don't understand.
Were you in class the last time? Because if not, you drag us back.
Yes.
If we're not in... Please, you know what? Let me continue with the mean, okay, so that we can handle this one later on. You can ask me back though, so that you don't drag us back. Okay, all right. I beg you, please.
Okay.
All right. So, so this is okay. So let's go to the next one that is involving group data. So mean with what? So this one was on group data. Let's go to mean with what? With group data. Okay, mean with group data. Okay, with group data. All right. So let's see, let me duplicate this slide again. All right, good. So let's take it this way, that with group data, let's say I have something like a table like this, 5 columns. Okay, good. Let's say we have, okay, something like this. Oh no, it's not how I wanted. Okay. Oh, I'm coming. This is not how I wanted. So let's say I want okay, let's see, let me get 2 here, 2 here, and 5 here rather. Okay, like this. So let's say we've been given a data like that. Okay, so let me tidy up here. Okay, I'll still keep what is here a little bit because I'm making use of them. So let's take it this way. You have a class interval. Okay, and then this is our frequency. This is our frequency. Okay, all right. So in this one, they've given us, let's say, in groups. Let's take it this way, that they gave us, let's say, in groups. So let's take it this way. They give us 10 to, let's say they give us 9 to 8. Okay, let's say they give us 0 to 9, 0 to 10. Okay. Okay, now let me make it 1 to no, I want the calculation to be easy. Okay, let's see. Okay, 0 to, okay, 1 to 9. Let me make it this way. 1 to 9. Okay, 10 to 19. Okay, 19 to 20 to 29. Okay, and 30 to 39. All right, so this one is for what? For group data. So let me get this one out here. Okay, like that. So this time I say marks scored by kids. Okay, in an exam. Okay, so we have what? So we have let's take it this way, that we have a 4. Okay, we have let's say 6. Yeah, let's say we have something like 5. Let's say 5, and then we have, let's say 2 here, 2, like that. And then we've been given, so this one is a group data. Great. And then the question is the pivotal question on the table is that we should find a word. Okay, let me duplicate this one and then this. Okay, so here, all right, we've been asked to find okay, so we've been asked to find a word. Find the mean. So we've been asked to find the mean. Okay, mean mark of the class. All right, good. So this is the question on board. So when we get something of this nature, okay, what are we going to do? So what we do is this. Here, you see, we're not giving just single interval. The thing is that they're giving to us in the form of what? A group. So when they give it to us in the form of a group, what do we do? So the first thing we do is to find a word, is to find something we call the class midpoint. Okay, so here, when they get something like that to us, okay, we find a word. We find something we call the class midpoint, okay? The class midpoint, okay, great. So with the class midpoint, okay, what are we gonna do? Remember, you add the lower class, okay, limit, and then the upper class limit, and then, so you add lower class limit and the upper class limit, and then we'll do it. So lower class limit, okay, and upper class limit, and divide it by 2. So here, let me take my tally here out. Okay, great. So what I need to do is that I need to find my word, class midpoint. So the class midpoint becomes our x. So x is no longer the age here because we're giving to, let's say, let me take this one out. Okay, so Okay, so let me bring this one here. Okay, great. So our class midpoint. Okay, so our class midpoint is where you add this and that and you divide it by what? You add this and this divided by, no, have I missed something? Let's see, 1 to 9. Okay, I think here should be, let's see, the difference is 9. It should have been 0 to, let me make it 0 to 9. Please make the first one 0 to 9, not 1 to 9. 0 to 9, so that the interval will be consistent. The interval will be, yep, make it 0 to 9 instead of 1 to 9. Okay, all right, good. Okay, so here I'm going to find my class midpoint. So what am I going to do? What I'm going to do is that I will add the lower class limit and the what in the upper class limit. Okay, the lower class limit and upper class limit, and I will divide it by what? By 2. Okay, so what is going to happen is that we are going to get here, 0 plus 9. Okay, that will give us 9 divided by 2, will give us 4.5. Okay, and this one 10 plus 19 will give us what? Will give us 29 divided by 2. So 29 divided by 2 give us a 14. Will give us 14.5. And then this one will also be what? This plus that's the 49 divided by 2. That will give us 24.5. And then the last one here will give us what? Automatically 34.5. Please, are we clear with that? So when they give us what? When there is what? So here, let me be making notes here. Okay, so when the data, when the word, the data, when we have what? When we have group data, okay, the words, the class midpoint becomes, okay, the class midpoint becomes a what? Becomes the X. Okay, good. So when we have group data, the class midpoint becomes the X. Okay, good. All right. So what are we going to do? So here we are going to find our fx. So this one, let me put my x here, like that. Good. So this times this. Please give me the answer. Yes. Please give me the answer. Yes.
18.
18. 18. Is it 18?
Yes.
Okay. Please, the next one.
87.
87. Please, my ladies, please make sure you double check the answers the men are giving. You know that I don't trust the men.
no.
I don't trust the men. So ladies, my ladies, are you there? Double check it for me.
Look, they are quiet too.
Hey, my ladies, March, when you are not talking, I'm not happy. I'm not happy. The way yesterday were giving me the genetics and stuff like that. Please keep the same temperature for me here. Okay. Please.
For this one, it's more calculation.
I beg.
That's why they are quiet.
Okay, so the next what's
5
that here?
122.5.
22.5. Okay, and the next one
69.
60 what?
65.
69. Okay,
yes.
Great. All right, so now we are going to compete for what? Our Sigma, our Sigma FX, right?
Yes.
Okay, so do the computation for me.
F?
Yes.
Sigma F is 17.
Here is 17. Excellent. And
296.5.
296 points. Please, it's what? Hello? Yes, please.
So for this one, for the frequency, that one will be provided. Not the frequency, that one will be provided.
I can give you a question whereby I won't provide it. After that, I'll give you a question whereby I won't provide it. It's not always that it should be provided. I can give you a question. When you finish, I'll give you a question. I won't provide it, and you are supposed to do it. Okay, so it's not always that I will. It's not always that it's be provided. Okay. After that, I'll give you one question right now. It shouldn't be provided. Okay. All right. Good. Okay, so please, what's the sigma fx here, please? What's the sigma fx?
296.5.
296.5. Excellent. Good. Now I'm gonna calculate my mean. So my mean, okay, is equal to what? Is equal to sigma fx.
Something.
Okay, good. Divided by what?
Sigma F.
Divided over sigma f. Over sigma f. Okay, so this will give us this divided by 17. What is the answer, please?
17.44.
17.44. All right, excellent, great. Okay, good. I'm going to give you another one that you are going to do, and in this case, I wouldn't help you. Okay, and then let's see you be able to do it. So let's say if I give you something like this, so I'm going to give you one, and then you will do it yourself without my help. And then once you nail it, then I know that you are who. Okay, great. So let me give you, let me see. Okay, so let's us duplicate this slide here. Okay, so let me duplicate this one. Okay, so if I understood this one, so that is beautiful, great. Okay, so let me give you another one. So let me take this. Okay, do you know where it's? Okay, I'm coming. So let me copy and duplicate this. Oh, okay. So I want this one to come here. Okay. Okay. Oh. I want the table to be more. Okay. Do you know where I can insert a table? Insert a table. Insert. Okay. So insert where? Insert a table. So so let's say I insert. Okay. Great. All right. Okay, so all right, so let's take it this way that okay, so ages of word. Let's take it this way. These are ages of word of kids. Okay, of students at a sick bay. All right, so let's say students at a sick bay. So age, then students. Okay, students. So let's take it this way that I'm going to have, let's say 4 to 9. Okay, 4 to 9. Okay, let me make it 5 to 9. 5 to 9. And then the second part, I'll make it
No,
10.
please, the screen is off.
Oh,
There is
mine is
a on
on.
your end.
The screen
Mine
is
is
still
on.
on.
Okay, so
Then
please
you check your network.
check the network and come back. Okay, so 5 to this, and then okay, so this one is difference to 14, and then 14 to 15, 15 to 19, 19 to 20, 19 to no, so 19 to what?
20,
24,
because it should be 20, yes.
19 to 24. Is that 24? No, 20. It should be 20.
It should be 20, 24, yes.
20 to 24. And then 20,
20 to 24.
25 to, okay, 25 to, let me make it
20.
Then
UCC.
29.
The ages I'm writing, so let me make it UCC hospital. So that one, little school kids can go there because the ages I'm writing, maybe it means that the teacher was also taken to hospital as well. So 25 to 29, and then so 30 to 34. All right, then let's say my frequency is here. Frequency here. Let's say I give you, here is 4, here is 6, here is 5. Okay, here is 8. Okay, here is 3, and here is 2. Okay, like that. And then the question goes, okay, the question goes, all right, find the word, calculate the word, the mean age. Find the mean age, okay? All right, start work. So this one, roughly, you have 3 minutes to do it. Start work.
Yes. Never. Never.
I had. Hello.
Bob, please, are we planning only the mean?
Yes, we are waiting for the. I'm
Yes,
waiting for you people to finish the calculation.
yes, because I had
I had
We are done.
18.07.
Okay.
18.143.
Okay. So let's do it together.
18.07.
18.07.
Okay. Let's do it together.
18.07.
So here, what you need to do is to find the class point.
19 years.
So our frequency here, okay, goes like that. So class midpoint will give us 5 plus 9 will give us 14 divided by 2, 7. Here,
12, 22,
will give us what?
32,
It will be what? 24, so 12. Here it will be what?
17, 22,
17, 22.
27.
32,
And then last one,
32.
and
32. Okay,
32.
so this times that will give us what? 28. This times 12 times 6.
72.
17 times 5.
85.
80.
85.
5.
22 times 8.
176.
176.
76.
And then
81.
81. And then
4.
54.
it's what? 54.
64.
Okay. It's what?
64.
64.
64.
64. Okay, great.
Yes,
Here,
64.
okay, great. And then please
506.
wait, the total here is what? Sigma F
20. So sigma F 28.
28. And then
And
FX.
sigma FX will give you 50.
Sigma FX will give us
506.
506.
506.
So here, when we compute it, what are we gonna get?
18.07.
18.
Point
So it is going to be
Yes. 18.0.
5 as a 506 divided by
28.
28.
and that will give us what? 18.07. Is that correct?
Yes, sir.
Yes,
Yes.
All right, great.
Yes, sir.
Good. Now look at what I'm going to give it to you. Okay, so let's say I'm going to give you data. Anybody with question here? Anyone with question? Anyone with question, please? Anyone with question? Before we proceed, anyone with question? I'm coming to give you tougher one. Okay, I'm coming to give you tougher one. I won't help you. You do it all by yourself. Okay, so let me start. So here, okay, so here I'm going to give you this one a little bit tough. Then you will do it by yourself. Okay, good. So let's see if I give you like that. Let's say okay, the ages of words. So here we are done with this one. Okay, so let's say let me take this one off. Okay, so the ages of people, of patients who reported at the UCC hospital this morning. Okay, so I'm gonna give you the figures here, and then you will do everything yourself. Okay, I won't help you. So here, 45, 19, 62, 21, 42, 27, 40, let's say 62, 56, 51. Okay, let's say, let me go to next line. 11, 70, 70. I've written 70 already. Let's say 68. Okay, 60. Let's say 81. Okay, 15. Okay, 60. 50. Let's say 41. Let's say 37. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and then maybe the last set here, 9, 5, 4. Let's see, 3, 5, 3, 7, 4, 5, 49, 85, 46. Let's say 76, 45. Okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. All right, then my first question goes: construct a frequency distribution in a distribution table for the data using a class word, using a class, okay, using the class interval. Let's say 1 to let's say 1 to 10. I'll give you 11 to 20, and then 21 to 30. Okay, 30. So you continue the rest, and then B, calculate the mean age of the patient. All right, great. Start work. So this one I'll give you, because it involves frequency table, I'll give you maximum of 8. If I should give this question to you in exam, maybe 8 minutes, you should be able to finish. So start work. Okay. Start work. So let me here's the one I'm giving to you. This what we did. This what we did previously. So let me duplicate the slide. So remember this one, there will be tally.
Sure. That will be sure.
Sir, your table has covered the distance for us.
Okay. Okay, I guess by this time everybody is done.
Yes, Doc.
Okay, so let's let me do this one, and then let me split this one. Okay. All right, so let's start. Okay, so frequency, yes, let's go.
1.
Here is 1.
Yes.
2.
Another 2.
It's another 2.
Yes, 4.
4.
Yes.
8.
Debbie.
8.
4. Another 4.
3.
1. 1.
Which one is 1? Which, I had 3.
No, it's not 3. 1.
Here is 1.
Yes, please.
Okay.
Then the last one is 1.
I can see only 176 here. Okay, so it's
Sir,
1.
please, the
11 to
11 to 20 is
20
not
is
2,
3.
it's 3.
It's 3.
11 to 20.
Yes,
20 is
It's
3.
3, it's
It's
not 2.
11 to 20 is 3.
It's
Yes.
3. Okay. So please be careful, because once you miss one, this
Just
one
one.
is dangerous. So,
And 81 to
Get 1
90
to
is
40.
also
8, yes.
81 to 90 is
which
2.
89 to 90 is 2.
80,
81 to
The
1
90.
to
last one
90. We have
It's
81
2.
here.
Yes,
We
81 to
have,
90. Let's start again.
okay, let's see.
It's 2.
81, and then we have 80 something again. 80.
85.
Where you say 85 is here? So here is 2.
Yes.
Okay. All right. Is everything fine now?
I think 71 to 80.
Okay. Do you know
71 to
which one is 0?
It's 1.
is
There is
1.
no
Okay,
zero.
let's start from the top. My lady, please provide me your answer. Don't mind the guys. Don't mind them. Don't mind them at all. I don't know who asked me to take the answer from the guy. Please, lady, let's go. Please, I'm starting. You. Okay, let's go. So number 1 is 1. Okay, next.
3. 2.
Yeah.
4. 8.
Okay.
5.
Yeah, it's 5.
Yes.
Yes,
5.
please.
Yes, please. 4.
4.
Okay.
1 and 2.
1 and 2.
All right. So please, you have to be very careful. Because this one, when you count this, so when you count everything here, it's supposed to be 30. So when you count everything, you should get 30 here. This, I remember SS one of Form 2 exam, we're giving one of them the values were 50. After doing everything, I finished the calculation and then I had 49, and I'm supposed to go all over again. It's really painful. So please make sure when you are doing, take your time. Like that's why you use the tally. Hello. That is why you use the tally. So when you use the tally, when you get it, you cross out. Okay. All right. So let's see now. Let's go for my midpoint. So 1 plus 10. Okay, will give me 11. So that will give me 6.5. No, 5.5, right?
5.5.
5.5 here. The next one will give me what?
46.5.
It will give me what?
46.5.
15.5.
No, that will give you 15. 15.5. Okay, that's 11 plus so 30. 11 plus 20, so 31 divided by 2. So 15.5. So the next one is what?
5.
So that will give you 25.5. So here 35.5.
35.5.
25.
Okay. Yeah, 45.5.
55.5.
Okay.
65.5.
5.5. Okay. 75.5. And then 85.5. So this time this will give us 5.5. This time it will give us what?
46.5.
46.5.
51.
51.
142.
142.
364.
364.
277.5.
277.5.
262.
262.
75.5.
75.5.
171.
171. Okay, good. And I'm going to find a word. I want the Sigma. I want the Sigma word. The Sigma effects.
It's 1,397.
1,395. 1,390.
95.
Okay, great. So,
my ladies.
The man, have you started crying?
No, sir.
No, you've missed a value here. You are finished. Here, all the calculations. You just get some of these ones that you get correct. Then the formula that you get right. Everything is down. You are get from the top down. You are get from the top down. My lady, have you seen that the men are no longer talking? You see, as it came to a difficult part, they are quiet. They started giving values. All right, so here
for amendment.
Oh no,
We are waiting.
We are just observing them. We just want them to just talk.
Okay, so what's the final answer here?
46.5.
30.
46.5.
46.5. Okay, excellent. Well done. Look at you, the man. Look at the voice I'm hearing. Don't you like it? Are you not happy?
They don't know.
Congratulations, micro class.
All right. Good. Okay, so I think you've done very well. Well done. Okay, good. So the next thing that we are going to, please mute your mic. Okay, so we are done with this mean. Okay, that's very good. The next thing we are going to talk about, and then we'll end the class with, okay, is what we call something very, very important. That let's see what we ended this one. Okay, so here. Okay, so Let me see.
Sir.
Yes,
Yes,
sir.
sir, please, can I ask a question?
Go
Sir.
ahead.
Yes, sir. A question.
Go ahead.
Hello, sir.
Go ahead, please.
Looking at what we have started with, sir, please, looking at this table, now there was a question that we added all the three. That is the modal, the median, and then the mean. Fine. But last Friday, what we did with regards to the modal and then the median, somewhere along the line, we saw that we are supposed to pick the upper class limits, the class less than, and then the other stuff. So in this case, when a question is presented, how is it going to be in order for you to know that when you are given all the three, that you have to look for all the three. I have to look for the upper class limit, the you add, and
No,
then
please go and
last
revise.
Friday's one was a bit different from this one.
Please, go and revise your notes, and if you have headache, you can message me back though. Please, okay, so that you'll be able to finish what you want to do today.
Okay.
Yes, go ahead.
Okay.
My question is, with the frequency of 30, no? So I know it's 30, but during the tally, no, you realize that probably somewhere is -1 or +1. So in that case, no, what will you do?
You can't be forgiving. There's nothing like +1 -1. This is clearly
So
30.
what I'm saying is that like when I was doing the tally, the 41 to 50 is 8, but I counted them as 9, but I knew the answer should be 30.
It's wrong. It's wrong.
I knew the answer should be 30.
Wrong is wrong. You
It's
can't
wrong.
justify
It's
the
wrong.
wrong.
There's no, when you don't have to justify the wrong. It's wrong. You will be marked wrong. Okay, so make sure there's no way you'll be forgiving. Okay.
Use the eagle eye.
So that's why you have, if you do the tally, I'm sure you didn't do the tally. When you do the tally, okay, when you do the tally, okay, you get
doctor.
Please go ahead. I'm listening.
+1, just temper justice with mercy.
No, please. We don't do that thing here in science. We don't do that one in science, please. When it is wrong, please. Okay, thank you.
Sir,
right.
If I decide to add the tally to the table, like we normally do the strokes, I believe it's acceptable. So I can
you have to do the tally. Honestly, you will be marked. When they give the data to you in this manner, we expect you to do the tally. That's why I put the tally in the table. So the tally will be marked. So the tally, when you do it, I'll mark like 2 marks. Because there's no way you can just use your eye. You even keep wrong.
All that tally 2 marks.
Yes, you have to do. You have to do for
only
2 marks.
2 marks.
All right. Yep. All right. Please let's move on. So we're going to talk about dispersion. Okay, dispersion. All right, dispersion. Good. Dispersion in what? In statistics. Okay, good. We're going to talk about dispersion. Okay, good. Now, when you talk of dispersion, what is the meaning of the word disperse? Dispersion, what does it mean? When you say dispersion, what does it mean? Okay, yeah. Spread. Okay, good, excellent. Okay, good. Okay, spread. Well done. So spread. Okay, good. Scatter. Okay. Okay, good. All right. So you can see that when you come to dispersion, what you want to find out is that how is your data spread? Okay, you want to see the spread in your data, basically. Is that not it? So you want to see how your data is what? It's the data that you have. How well spread is what? Is the data. Okay, good. That is what the dispersion is basically about. Okay, we want to see how well our data is what? It's spread or is scattered. Okay, the data point, how well is scattered, maybe around or from the central point, basically. So the dispersion, as you just said, you said spread, you said scatter. That is beautiful. So when we talk of dispersion, what all I want to do, we want to see what so it describes what? It describes how the data points are what? Are spread, okay, either around, I can say around, or word, from the central value. Okay, so you know we have the central value. The central value could be what? Could be mean, mostly mean, or what? Or median. Okay, mean or median. Okay, great. So the central value could be mean or median. Then we want to see how well the data is what? Is spread. Okay, so that is when you measure what? The dispersion. Okay, so there are so many forms of dispersion that we can talk about. Okay, so we want to see that is the data well spread. Okay, great. So I will give you a particular scenario here. Okay, let me take this thing out for now. Okay, so let's see how well the data is spread. Okay, like that. All right, so let's see. Let's take it this way. That you see, when it comes to the spread, okay, depending on what is at stake, will let you know that, oh, this is the spread you are doing, or okay, it depends on what is at stake, what is of your interest. So your interest at stake will tell us what sort of spread, whether you want this spread or the other. Okay, is the question at stake. Okay, let's take it this way. Somebody comes to you, and the person, let me even take a blank page for this one. A person comes to you, and then the person tells you this, that when he go, let me pick this one. Let me pick something, this picture on the online. So let's say the bull's eye. The bull's eye. Let's say bull's eye in okay, good. Let's say this game. Let's say, okay. Okay. All right. So let's see. All right. Good. So somebody comes to you, and the person is telling you that as for him, okay, as for him. So let's say dispersion. So we are interested in what? The spread. Want to know the spread of the data. Okay, great. So let's say the person comes here, okay, and tells you that, oh, as for him, he's very, very good with the bull's eye. Okay, when it comes to the bull's eye like this, okay, all right, like that. Okay, so let's see. This is the bull's eye. Then he throws the bull's eye, and he tells you that he's going to make 10 throws, but his average score, okay, usually when he throws that he lands in where? In 1. That's what he told you. That most of the time when he throws, he lands in 1. So let's see something. He's going to throw. Let's see something here. So let's see. He throws the first one, it lands here. Let's see, draw. Let's see. Let me take black. So he throws the first one, it lands here. Okay. He throws the second one, it lands here. He throws the third one, it lands here. Throw the next 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 one, it lands here. 1, 2, 3, 4. Next one, it lands here. The next one, it lands here. Okay, how many? So now he has thrown 10. All right. Okay, have you seen the throw here? Have you seen the throw here? You can see clearly that if you look at the, hello, are you there? Okay, great. Okay, all right. So if you look at his throw, you can see clearly that, okay, you see, whatever he told you was a lie. This is somebody who is coming to look for a job, and he lied on his CV. You can see that he has taken 10 through. He didn't even land on the second cycle. He didn't even land on the third cycle. All the through were far away from it. Okay, great. So you can see that even his hand position will let you know that he's data is not even widespread like that. You can see he's close at a particular place. He doesn't even come near here. Anytime he closes, he's up there. He's up here. He doesn't even come down. Okay, good. So here like this, you can see that the word in terms the data is not well spread like that. Okay, for this particular person. Okay, good. Now let's take another person comes. The person comes, he takes the tray, one tray is here, another tray is there, another tray is here, another tray is there, okay, another tray is there, another tray is there, another tray is here, one tray is there, one tray is there, one tray is here, 1, 2, 3, okay, so last one. So the last one is here. You see, when it comes in terms of spread, okay, look at the second person's true. So this is A, true. This is B, true. You can see that the B is well spread compared to what A. Have you seen it? Can you see what I have on my screen? So you can see that in terms of the spread, here they are pretty close. This one is quite spread. So sometimes, depending on what you want, sometimes you don't want the data to be widely spread. Okay, depending on what you want. Let's take it this way that you are measuring what you gave some work to people. Let's say you are marking scripts, okay, and then when you are marking scripts of people tracing something on a graph sheet, okay, maybe because the hand is not all that the same, you expect that, oh, maybe the answer is 1.2, okay, like that on the graph sheet if you do it correctly. But you expect that people should have maybe 1.1, 1.3, 1.2, 1.1, 1.3, like around that. If somebody come and then give you answer of 1.7 or 1.8, you can see that clearly this one is wrong. But if this is correct, we expect that, oh, the answer should be 1.1 to 1.3, okay, because you are using freehand tracing, so it's not going to be so the spread shouldn't be all that much. Okay, good. So when it comes to spread, it's something we consider quite a lot in data sets. Okay, let's take it this way that you are going to do an outreach. You want to educate people. You see, when you want to educate people, you want a situation that you want to target almost all age classes. So if you receive the data, and then when you receive the data, you realize that all the people there, okay, belong to a particular age. Okay, all the people there belong to a particular age. Definitely, you will not be all that happy because you want to reach out to a lot of people as possible, different age groups. Okay, let's take it this way that for instance, let's say you are going to educate people about sexual transmitted diseases. Okay, when you go there, after your data, you expect that you want all age groups. Okay, you want that when you take the data, you want people even as low as JSS, okay, to SS or to the grown-ups. Okay, you want almost all age groups to be present. Okay, so the dispersion will tell you, once I get the data, the dispersion will tell me what sort of word, what sort of variability. So here, the dispersion tells me the variability in the data set. Okay, the dispersion will tell me about the variability, okay, in the data set. Okay, that is what the dispersion is going to tell me. Tell me how the spread, how variable are they? You understand that? How spread, how variable, that different stuff, okay, different people they will reach out to different people, So for instance, if I meet people and let's take it this way, let's say I have age group, let's say age group 1. Okay, let's say age group 1. And then people I talked to, the age group were 20 21, 20, 21, 20, 21, 21, 21, 20, 21. Okay, all right, like that. And then we have the what? We have the age group 2. Age group 2, we have what? We have 20, 21. Okay, so 20, 21, 23, 24, 26, 30, okay, 19, 35, okay, 30, 21. Okay, great. Let's say something like that. Clearly, now look at the question I'm going to ask. You see, if I want to reach out to, if I ask you that which one has higher variability, which one has higher variability? Yes, which one has the, yes, age group 1 or age group 2? You can see that it's age group 2. Age group 2 has what? Higher variability. But the age group 1 is almost consistent. It's just 2021, so it's consistent. Okay, so depending on what is at stake, okay, sometimes if you want to reach out to a lot of people, you want the what? You want the thing to be variable. But sometimes you don't want that. For sometimes, if it is something you want to do, if it is if you want something to be uniform, you don't want variability to be in it. No, I just want certain group of people. You don't want it to be variable. That one, you prefer this over that. Okay, you want just consistent, like you want consistency. Okay, you pick this. If you want consistency, you pick this. Okay, but if you want, okay, you want variability, you want to reach out to different groups, you will pick what? You will pick that. Okay, so it depends on what's at stake. Okay, all right, great. Now, why is this spread thing very, very important in statistics? Okay, why is this spread thing very, very important in statistics? So when you come to this spread, okay, the spread will actually help us to know, okay, the reliability, okay, whether the reliability of the data set, or more or less the what it tells us whether the data set that we have is reliable. For instance, if I ask somebody to go and measure the length of a table, and then when he measured this one, the following day when he went there, he came out with these values, like that. Okay, he came out with these values. Okay, let's say he measured the first set of the table, and then he said that when he measured first day the length of the table, he had 20. Second day he had 21. Okay, third day 20. Next time 21, like that. Okay, and let's take it to another person. Another person also came, measured the length of the table this way, and then like the whole length of the table the whole month. And then another person measured this and provide this data. Which of these data is reliable? Which of these data is reliable? Yes. Let's take it this way, that this one measured the table, length of table, provided this data. And then length of table provided this data. Okay, the following one group, they did it, they measured this like that, and then provided this data. Okay, which of these data would you think is reliable?
Group 1.
Group 1 is reliable. You can see that the data is much more consistent. Okay, so if it is consistent, it means that it is quite reliable. Okay, so what dispersion, another thing that dispersion tends to tell us is that, okay, another thing what dispersion tends to tell us, so dispersion, okay, dispersion in what? In stats, okay, what it tells us is that it tells us the what? It helps us to know the what? Whether the data, the first one I talked about, I said what? The variability in the data set, okay? So it shows the variability in the data set. Okay, that's what the dispersion is going to tell us. Okay, another thing that dispersion can also tell us is that it can let us know whether the thing is what? It's actually reliable. All right, so in this case, if somebody measured the length of a table, okay, for a whole month and provide this data. Okay, another person measured and provide this data for the month. You can see clearly that this data here, the down here is not reliable. So another thing that this person can do for us is that, okay, it tells us, or it shows whether the data set is what is reliable. Okay, all right, so it tells us the reliability of the data set. Another thing that is also tells us is the consistency. Is it consistent? Consistency. Okay, just like the bull's eye. So if I throw 10 times and I hit here, I hit at 2, it shows that no, I don't have the spread. It's anytime I throw the bull eye, I will land here. So you can see that I'll be around. If I throw 10 times and all landed here, like here, like that, then it means that I am quite consistent in getting the 2. Okay, so another thing that you can get is it shows the consistency in the data set. So if the data is consistent, what it means is that there is in terms of spread, the spread is what? The spread or the dispersion is what? Is low. So if the data is consistent, it means that, okay, like this one, you can see that this data is consistent. So here, the dispersion here, the dispersion is what? Is low here. But here, this one is what? It's quite variable. It's quite variable. So if it's variable like that, the dispersion is what? The dispersion, the spread is high. Okay, great. All right. So these are some sort of information that we could get from this one, from dispersion. Okay. All right. This is some information we can get from what? From dispersion. All right. Great. Okay. Any questions so far? Any questions so far? Any questions so far, please? Okay, all right. Now, what are the measurements of dispersion? When we talk of dispersion, what are the things we measure? Okay, so let's see measurements of what? Let's see measurements of what? Measurement of this dispersion. So measurements of dispersion, we have what? We have the easy one, very easy ones, like what? Range. Okay, range. Okay, good. So range is what? Range is basically, when you talk of range, we have range. So range is basically the difference. Okay. The difference, okay, between the highest and the highest variate, okay, and the least variate. Okay, in the data set. Okay, so for instance, if I give something like that, 2, 3, 7, 9, 12, 18, 30, okay, 35, like that. And you ask me to find the range. Okay, so the range will be equal to what? Will be equal to 35 minus what? Minus 2, which will give me what? 33. Okay, all right, good. Okay, under the range, we can also get, sometimes we can also get some sort of range, like some various forms of range, okay, which we will deal with it. Okay, we will deal with those various forms of range. Okay, all right, good. Okay, that will be the last thing that will, let me check my time. Okay, good. So we have the what? We have the range, as I've talked about here. So this range is very simple, straightforward. Okay, But we occasionally have something like inter-quarter, okay, inter-quarter range, okay, like that. We have various types, and then sometimes we can even go ahead and get something like a semi-inter-quarter range, okay, this one. So here we'll talk about these ones, okay. So these are various forms of range, but we'll talk about these ones in cumulative frequency. So that's the thing that we'll end the class with, because it involves graph. So we want to do the ones without graph, and then we'll tackle these ones, okay. So these ones, we can also get something like this, okay, as part of our range. Okay, great. So this is what, so we can do the what we can do for range, okay. Another thing too that we can also get is what is another popular one is what something we call variance, okay, variance. So two is what is variance, okay, variance. All right, variance. Okay, great. Can you tell me something about variance? Yes. Can you tell me something about variance? Variance, yes. You can tell me something about variance, yes. Okay, yes. Okay, yes. Okay, variance. So variance and what? In fact, honestly, variance and standard deviation, they go together. Okay, so we have the variance and what? So I will do the variance and something called standard word deviation. Honestly, they go hand in hand. And what they do is that the variance, as we said, so when we have the word, when the variance is low, okay, what it means here is that there is no much variation in the data set. Okay, so which means that, okay, so here when we come to variance being low, what it means, okay, so low variance, so here, okay, so it measures spread. So low variance means what? Low variance, okay, means there is what? The data is what? The data, the virate, okay, the virate or the data point. It means the data point, are close. Okay, so there's no much differences in it. Okay, the data points are close. Like the bull shots that I talked about previous one. So if I throw all the points and all of them hit here, okay, at the top here like that, at one place like that, not so, which means that my variance is low because all of them hit at a particular position. So that will give us what? Low variance. Okay, so when the variance is low, it means that the data points are what? Are pretty close. Okay, all right, they are pretty close. Okay, to the what? To the maybe the central value, to the mean. All right, good. So here, the variance also help us to to describe the spread in the data set. And another one, okay, the two of them, they actually work together. That is the standard deviation and then the standard deviation and the variance, they work together, okay? Because once you calculate the other, then automatically you calculate you find the square root of the other one, and then will also help you to calculate the other. Okay, great. So when it comes to the standard deviation, so the standard deviation also measuring the spread, okay? And then when you have low standard deviation, if you have low standard deviation, what it means here is that the data is what? It's actually, they also close. Okay, so high standard deviation means that spread. Okay, so here, just like this one, just like the variance. Okay, so another thing that we talk about is what? So when we have the what? When we have low standard deviation. Okay, what does it mean? So low standard deviation means that the virate or the data points are close to the mean. Okay, and when there is what when the standard deviation, when the SD, okay, close to the mean. Okay, all right, and then when SD is what is high, okay, it's high, okay, it means there is what, when the SD is high, it means that the data, okay, the data points are what, are spread away. Okay, they are spread, okay, away from the world. They are spread, okay, away, okay, or maybe not necessarily, like they are spread out. Okay, spread out. Okay, they are spread out from the mean. Okay, great. Now, so this is more or less some sort of overview, okay, of what I've talked about. After the range, we'll revisit the range, okay, again. But the next thing we're going to do is more of what? We're going to do more calculation on these two, okay, on these two. Okay, great. So we duplicate the slide here, and then now we can talk about what? So remember, I can get a data set. I can get a data set like this, okay? Okay, let's say I have a population like this. I have a population. You know, population means that everybody is included. So when I have population, I have 2, 4, 6, 8, and 10, like that. So population. So you can see that everybody in the population, let's say my population has how many individuals? Has 5 individuals, right? Okay, very simple. Okay, my population has 5 individuals here. So my N is equal to what? My N is equal to 5. 5. Simple. You can also ask me, that's the number of individuals, say they are 5. And then you can also ask me to calculate my what? My population mean. So population mean, pop mean. And pop mean will be equal to what? What's my pop mean here? My sigma what? So my sigma, what is my sigma? So my population mean here. So my population mean here is what? Sigma S over what? Over N. Okay, so that will give me what? The sum is what? Please add everything for me. So what is my mean? Hello,
30.
what is my mean? When I add
30.
So 30 divided by 5. So the mean is equal to what?
6.
Okay, excellent. Okay. So you can see that when I'm using everything, that's population. All right. Good. If I'm using everything, that's population. Okay, great. Now I'm going to find out how am I going to what? I'm going to calculate my variance. In exam, I'll give you the formula. You don't need to put the formula in your head, but if you memorize it, that's fine for your own sake. Okay, but the reason I'll give you the formula is because I'm not going to test how to memorize formula. I want you to see how you can use the formula to understand the concepts that we are talking about. So I want to know about what? The variance. Okay, so let's say I can see that I have data, population data, everybody here, and I want to get the variance. So first of all, there's something that I need to do. Okay, so I want to see, you see, because everything that we are doing, the central value I want is the mean. So you can see that in this my population here, okay, this is my population. My central value for this particular, my central value here is the what? Is the mean. The mean is what? 6. So I want to see the variance, okay? What is the variance of this particular value so far as the word. How are they spread? How are they close? Okay, or how are they spread or close to my central value, which is the 6, which is the mean in this case. So how do I go by that? Okay, it's very, very simple. As I've told you, I'll give you word. In that case, I'll give you the formula. In always in this, I'll give you the formula. But if you know, there are so many formula they use in doing this one. Okay, so it is up to you, the one that you are comfortable with. Okay, you don't necessarily need to stick to mine, but in the exam, I'll give you formula so that, okay, great. So let's see what we're going to do. So what I'm going to do is that I don't like to teach with formula. I don't like to put formula here. Okay, so let's see. So what I'm going to do is that I want to calculate variance, but look at what I will do first. So first of all, I want to find, I have my mean here. So I want to find something we call deviation. Okay, mean word, mean, okay, mean deviation, okay. All right, I want to find my word, my mean word, deviation. Are you with me? Okay, I want to find my deviation like that. Okay, you see, the one that I'm giving here is not in table 4. The values that I've given here is not in table 4. Okay, it's not in table, just they are simple individual values. So first of all, I'm going to find deviation from the word, deviation from the mean, Okay, good. So I'm working on variance now. Let's see what I'm gonna do. So deviation from the, I know my mean is 6. So let's say, let me put some small table here. Let me put some small table here. Insert a table. Okay, you know, I want it here. Insert a table. Oh, okay, it doesn't matter. Okay, then let me duplicate this one. Okay, because I will need this one, but I will need the table here. Okay, so insert a table. Okay, so let's say, okay, I need that. Okay, 4 is fine. Okay, no, okay, good. 1, 2, no, that's too small. We'll go back, insert the table. Okay, that's fine. Okay, great. So let me bring it here. So I'm working on variance now. All right, great. So let's have my values. So my values are x values are what? I have 2. This is not frequency table. 4, 6, 8, 10. Okay, great. So let's see what I'm going to do. Okay, let's see what I'm going to do. So first of all, I'm going to find something we call deviation. So what is the mean deviation? So I want to see, how are the data deviating from the mean? Are you with me? Look at what I just said. How are the data deviating from the mean? My mean value is here. Okay, my mean value, let me go and take the mean symbol somewhere. The mean symbol, yep, here. Okay, so let me bring my mean symbol here. Oh, why? I don't know how you do that. Oh, let me see why the mean symbol is behaving. Okay, let me take the formula here. Okay. All right, good. So let's say I've gotten my mean symbol here. So my mean symbol, my mean here is equal to what? 6. All right, great. So let's see what I'm going to do. As I said, you have to know how to go by what I'm doing here. So please make sure you pay attention. So first of all, I want to find deviation from the mean. So deviation from the mean, let me put here G. Okay, so D is equal to what? So let me say D, small letter D is equal to what? This D is equal to X minus what? X minus the mean. Okay, X minus the mean. Oh. Oh. I don't know why this thing is behaving like that. Let's see. What it's working. Okay, good. So it's not coming. Okay, okay, so I need to get this here. Okay, let me see if I pick it online whether it will come. Okay, mean symbol. Okay, so let's say okay, so let's see. All right, even this one is even the correct one. Okay, let's see whether this one come. Okay, and then let me see if I pick this one here. Okay, let's see whether it's gonna come. Okay, great. So the next thing that is what I'm going to find how these values are deviating from the mean. Okay, please, I hope you're paying attention to me here. So first of all, all right, so here the mean is 6. So here will be what? 2 minus 6. And what will I get? I'll get negative what? 4. Here I will get what? 4 minus what? 6. I will get what? Negative 2. Then I will get what? I'll get 6. 6 minus 6, which will be what? Which will be 0. Remember my mean is 6 here. And here will give me what? 8 minus 6. That will give you what? 2. You don't need to write that before you write, because we are learning, that's why I'm writing it. But when you are doing, you can do it straightforward. And then here will give me 10 minus 6. That will give me what? 4. When you finish, you square this. So here now, what are you going to do? We'll get what? D squared. D squared. So D squared means that the answer that I've gotten here, all right, the answer I've gotten here, I'm going to square it. Remember, anytime you square negative answer, you get positive. Listen, be careful when you are pressing it on the calculator. Okay, I've seen some people, the calculator has been programmed in such a way that if you want to square value on the calculator, okay, unless you bring brackets like this, and then you square, okay, you square it like that, okay. If you do is if you just press negative 4 on the calculator straightforward, it will give you negative 16, but that's not correct. Okay, negative 4 or better still negative 4, unless you bring what? You bring a bracket. Please take notice of that because I've seen people miss that. So here, this is my deviation here, which is equal to what? X minus what? The mean. Okay, and this one will give you what? This one will give us what? This one will give us, so this one will give us, put it at the back of your mind that the D squared will only be positive throughout. Put it at the back of your mind. It will never be. So 16. The next one is what? The next one is 4. 4. The next one 0. The next one,
4 and 16.
And 16 again. All right, good. So how do we calculate variance? So variance is simple, but we have 2 ways of calculating variance. You see that I've written population here. I've done that deliberately. I've not written sample on the screen. Population. Okay, good. So let's see. Okay, let me copy this. Copy, paste. All right. So Population variance is given by what? The variance is given by, okay, d squared, okay, all over, okay, so d squared here, d squared, all over, and that is what we are doing here is for what? Population variance. Okay. Now, most books that you will use, okay, this variance usually it is indicated by what? S squared. That's what some books will write. Okay, it's correct. Okay, like that. And I've written here the variance here is given by what? It's given by d what? This d here, but this d is sigma. Okay, so let me go and bring my sigma. Where is my sigma symbol? Sigma here. Okay, so sigma. Okay, good. So the sigma d squared, okay, over n is the population variance. Okay, but most books that you read, they will represent the variance is represented by s squared. In most books that you read, you get to know why they do that. Okay, but I want you to understand. So I will keep V. I will use V for it. It doesn't matter. I will use V. Okay, I will use V for this. Okay, for now. Okay, great. But you get to know why they write S squared. Okay, good. So from here, look at what I've written. So the variance here is going to be what? The D, the deviation. D here, this D. Okay, all right. Deviation from the mean, which is what? Which is the D, is equal to what? The mean, okay, the mean here, this, that, okay, this one, oh, why is it that? I don't know why. Okay, all right. When I copy and paste, I don't know why this one doesn't come. Okay, good. Okay, I've seen what I need to do. All right, like that. So the D here, this is the deviation, which is this D squared, that's, and then the mean deviation is given by what? The sigma of this. So let's see, we are going to get what? Our sigma D squared. Here, our sigma D squared, please, what are you going to get here?
40.
Yes. 40. It's what?
40.
Good. All right. And then here, what is the number here? Here it is, you can see that you are not going to add these figures. So it's 1, 1, it's individual. So 1, 2, 3, 4, 5. So here, okay, n is equal to 5. Okay, good. So n is equal to 5. So my variance V, this population variance is equal to what? It's equal to the sigma D squared. Okay, so the sigma, okay, I wish I could write D squared easily. Okay, good. So sigma, okay, so the sigma D squared over n, so that will give me 40 divided by what? 5.
5.
And what is the answer am I going to get? It's what?
8.
8. Excellent. That is all. Please, is there any difficulty in this one? Hello? So when you give me a list of values like this, okay, list of values, and I should use everything, I assume that these values are for population. So when I'm calculating, look at what I've done. Very simple. Okay, yes, please. Hello, do you have a question?
No, sir.
Good. So here, simple like that. Now, do you know what? Do you know the relationship between standard deviation and what? And variance is that when you find the square root, so let's see, insect. Okay, good. Let me insert the equation here. Oh, good. I can even insert equation. So let's see. Let's see equation. Let me do. Okay. Let's see square root. Okay. Let me insert equation here. Okay, great. So let's say, okay, and then okay, so let me go for equation. Okay, good. Now let's see equation 2 here. Good. So let me insert okay, now you know I can insert equation. So square root radical equation. Okay, good. So square root here. Good. Okay, so let me take this one away. I've inserted equation. So do you know what I can? Okay, all right. So let me insert equation here again. Now you know I can easily insert equation here. So here, let me go here. My v equals what? V equals. Okay, so let's see. Let me put fraction here. Okay, so let me take this one away. My v is equal to d squared. So d let's see insert again. Oh, this equation will delay me. Insert again. Okay, so equation here. Oh no. Okay, so then I put what? So here I want the exponent. So let's say, okay, okay, so this should be, okay, the top one, okay, should give me this. All right, so let me take this one out. Delete this. Okay, so let me delete what is here. Oh no. Hold on. Okay, good. Let me delete this one. Okay, good. So here I had my word d squared over what? N. Good. Now I want to see that. So the relationship between where standard deviation is equal to square root of variance. That is all. Are you with me? That is all. You are done. Are you with me? So whatever value that we had here, if you ask me to find the standard deviation of this, so let's say from this calculation we did, okay, from this calculation that we've done, okay, so this is the, okay, this is the deviation. Remember, deviation d is this, okay. Most books that you read, they will give you this, okay. They will not use d that I've done here, okay, but I have shown you d on my table, so like that, simple. Or if I don't want to write that, okay, so here let me put sigma. Okay, I've missed something here, sigma. Okay, so let me put my sigma here. Okay, good. So sigma d squared over n. I'm done. So when you finish the standard deviation, okay, so standard, let me write this one first. Okay, so I'm coming. So let's say, let me copy this, put it down here. So standard deviation is equal to what? It's equal to square root of what? Square root of variance. That's all. So once you know your variance, if we find the square root of it, it will give me the standard deviation. Please, are we clear with that? Are we clear with what we just did?
Okay, look.
Yes, please.
Yes, so with this, can you say variance and deviation are not the same?
But they are never the same.
They are not the same. Okay.
They are never the same. Square root of this, when you get this answer and you find the square root of it, most of the time, sometimes they can even ask you to. There are a lot of complex formulas you can use. There are a lot of them.
Yeah, but they are complex because what I have here is
No. Forget about complex. I'm simplifying everything for you. you can, there are so many complex, those of you who are math inclined, there are so many complex formulas you can use. But what we are doing, I'm just simplifying. Okay, if I ask you a question, I'm not testing whether you know how to do it. What I'm testing is you using the whether you understand the concept to apply in a scientific context. That's what it means. Okay, great. Okay, great. So let's see. So the standard deviation here is equal to what? It's equal to the square root of the variance. So once I get my variance and I find the square root of it, I'll get my standard deviation. If I have my standard deviation and I square it, I'll get my variance. Okay, so those people, those books that you see that they've written that the variance, they've written square. You see, so those ones, so which means that if I write what? If I want to find the word variance, I can square both sides, right? You square both sides. So when they write s squared, if they find, so some people, if they are finding the word, the variance, if I want to find the variance, which means that I will square what? I will square both sides. Is that not it? If I want to find the variance, if I want to find v, I will square here. I will square this and square that. I will square both sides of the equation like that. Okay, I will square both sides, and then eventually this will cancel this, and then so square of standard deviation. Okay, all right. So which means that the square of standard deviation will give me variance. Okay, and then variance is also equal to what? So the variance is when I find the square root of what? Of variance will give me standard deviation. And if I want to get variance from here, I will square the what? The standard deviation. So that's how come most of the books that you read, you use the S. So the S that they have squared is actually the standard deviation. Okay. Okay, good. That S squared that you've seen, the S there is standard deviation. Okay, good. But when you understand it, it's not about the formula you use. Make sure you understand it. Okay, I calculated my deviation, squared my deviation, find my sigma deviation, sigma d squared over n. Okay, like that. I get my variance. Square root of the variance. The answer I will get here, the square root of it is my standard deviation. That is all. Okay. Any questions so far?
Oh, yeah, Doc. So, in a nutshell, what you are trying to say is that you can be given the standard deviation for you to calculate for the variance, and for that matter, you square the square root of the variance, and then you the square root to cancel the square to give you the SD to the SD squared, right?
Yep.
Okay. Okay.
Doc, please, we have previous slides that we have. What they did was that with the variance, they did the calculation up there, and then the n, they did it like n minus 1. What about that?
Oh no, don't worry. We'll come there step by step. You see, I've written population here. When if you go back and read it, follow what I'm teaching. I know what is in that slide. Follow what I'm teaching. Okay, I know what is there. Okay, so please don't worry. I know what is in that slide. Okay, follow. You see that I've written population here. Okay, we'll come to that one. So what is here is population. When they've given me a list of values like that population, if they tell me it is population, I will use what I have here. Okay, we have a case that you are going to use that one. Okay, we'll come to that one. Okay, good. Now, let me give you a question, a simple question here. So let me give you a question. Okay, so I'm going to give you a question here. So yes, please.
It means that with the value we had for the variance, which is 8, if we have to calculate for the SD, then the SD will be 2
square root of 8. Square root of 8.
Yes, square root of 8, which will be 2 root 2.
2 root 2, yes. That is it.
Yeah. All right.
Okay, so now you solve this one for me. Okay, so you solve this one for me. Okay, so let me duplicate this. Okay, let me duplicate this one here. All right, so still I will still keep the word population there for a reason. Okay, still population is there. for a reason. Still population is there for a reason. Okay. Okay, so I'm going to give you values. So let's see if I give you value like the 15, okay, let's say 21, okay, 17, okay, 18, okay, and then okay, and 29. All right, good. I've given you that, okay. And then the question I asked, so first of all, A, find the mean. The mean. B, the word find the variance. C, standard deviation. Start with.
Hello, sir. The mean is 20.
No, please you go. Please do all of them. Finish everything. Do everything. Do everything. I want to see everybody working. Okay. Most of the time, when you tell your answer early like that, some people will not be working. I want to see everybody working. I want to see everybody all hands on deck. Okay. I want to see my ladies working. I don't want the men to dominate and they will come and tell me, no, the ladies are suffering. No, I want to see my ladies working. Okay, good. Let me see if I can even insert somewhere here. Let's insert. Okay, I can. Let's see.
Oh yeah.
Oh. All right, great. Okay. So can we solve it together now?
Okay, dog.
All right, good. So let's see. So first of all, what is the mean? When you calculated the mean, what did you get here, please?
Because I had the mean to be 20.
20.
Yes, dog.
What did you get? 20? Is it agreed?
Yes, dog. Yes, 20.
Yes,
20.
yes, the mean is 20.
So the mean is what? Is 20. Okay, great. So now that the mean is 20, what am I going to do here? So I'll write 15 here. The next one is what? 21. The next one is what? 17. The next one is 18. Next one is what? 29. Great. 29. All right. So total number 1, 2, 3, 4, 5. So n is equal to what? N is equal to 5. Okay. Now let me go to my deviation. Okay. So deviation is what? Deviation from the mean deviation, right? So the deviation here is going to give me, so then my mean here, you know, it is equal to 20. So mean equals 20. So we are going to use our mean. So the mean, okay, is what we have here. So let's see what we're gonna have. So that will give us what? 15 minus 20 is what? Negative 5. Okay, do you know what? Let me tell you the trick. There's no need for you to see when you are work it this way. Work it like that so they don't go back and come. So this one quickly, then you write 25. Don't waste time. Okay, you square it. Okay, have you seen this? So you don't waste time. That's a trick. You don't waste time. Then the next one,
That is 1.
It's what?
1.
Okay, good.
So
okay.
This one is 1.
It's 1.
It's what? Here is 1, and so it's what?
Yes, dog.
So here was 1. Okay, good. This side
to be 9.
3.
So what? Price is what? 9.
9.
Negative 9, right?
Negative 3.
Negative 3 here.
Dog,
Yes.
negative 3.
And this side is 9, right?
No.
Yes.
And here is negative 2.
Negative
And
2.
this side is what? 4. Good. And here is what? Here is positive. This is positive 9.
1.
And here is what? 8. 81. 81, sorry.
81, dog.
81. Excellent. Good. Now I'm going to sum up everything here. So sigma d squared is going to give me what?
No, 39.
It's what?
It's what? 39.
The sigma d squared is equal to what? Hello? That's 9. Okay. That's 9. Okay. Good. It's what? What did you get? Sigma d squared when you are adding everything. It's what? What did you get?
120.
120. Good. So this will give me 120. And n is 5. So my variance is equal to what? Sigma d squared over n. Population variance is sigma d squared. That good. So 120 divided by 5. What am I going to get?
24.
24. Good. So with the 24, that gives me my variance. Okay, so the variance is what? The variance is 24 here. Now I want standard deviation. So the standard deviation.
24.
Good. So my SD.
4.4
is equal to what?
4.39.
Okay, square root of what? Let me see. Get this one. So that gives me this one. So this is my variance here. Okay. So with this, my variance is equal to my standard deviation equal to the variance, which is what? 24 here. Like that. Good. The square root of 24 will give me, what is the answer?
2 root 6.
SD is equal to, the SD is equal to
4.89.
4.89. Excellent. Okay, great. So there's no headache here at all. All right.
Yeah. Hello,
Good.
Doc.
Yes, please.
Yeah, please. My problem is that I didn't follow quite well the arrangement under the X, you know.
Which arrangement under the X?
That is 15, 21, 17. Why didn't you arrange maybe 15, 17, 18, or?
It does. I just give random values. It is up to you. You can choose to arrange it in order. I just gave random values. You can make it.
Okay.
It doesn't matter. Okay. You can make it in order.
Okay.
It doesn't really matter.
Okay.
Okay, good. So now that you've done this one, please go ahead.
Yeah, please. So,
yes, please go ahead.
Is it composite that you leave it in 2 decimal places or?
Yes.
Well, if I want you to leave a specific one, I will specify. But if not, I'm leaving your answer in 2 decimal places more of standard. Okay.
Okay,
great. So let me give you the last one. Okay, I'm not going to help you. Okay, make sure you master this one, and then I will see that you are cool. You are who? Okay, so let's see if I give you this one. Okay, so if I give you 20, 21, 29, 19, okay, 11, okay, 17, okay, 33, 1, 2, 3, 4, 5, 6, 1, 2, 3, 4, 5, 6, okay, 1, 2, 3, 4, 5, 6, 7, okay, then let me add 10, okay, 10, okay, great. All right, now without my help, okay, so what, okay, do you know what? Right now, I want your head to spin. So look at what I'm going to do. I want your head to spin. Find the standard deviation. Start work.
So only the standard deviation.
Yes, but you see, for to find the standard deviation, you have to go through all the procedures.
Find the mean.
Have you seen it? So exactly. So so one question like that is even much more dangerous. Okay, good. So now the question is just find the standard deviation. That's all. Okay, so you find your mean, you calculate your variance, find the square root of your variance. You are done. Okay, great. Okay, so this one without my help. Yes, all hand on desk. Will you get decimal in the mean? When you get decimal in the mean, let me know.
No, we didn't get decimal.
Yes, sir. There is decimal.
There's a decimal.
Yes, sir.
No decimal.
There's no
No,
decimal.
there's no decimal.
It's not true. It's not true. There's no decimal.
Okay,
Decimal.
there is decimal.
What are you saying? There is decimal.
But the
Let me
answer
see.
is 14.1.
No.
Add all of them divided by 8.
Yes.
Divided by 8.
No decimal. No
There's no
decimal.
decimal. There's no decimal. I just put it in and then check it online. There won't be decimal.
Okay.
Hey, one man is already down now. Hey, please be careful. Because once you miss the mean here, it means that everything down, you are dead throughout. I beg you. So you have to be very careful when you are doing the calculation. Because once you miss number one, it means that all the way down. Okay, so please be careful. The men, my ladies, I know you'll be fine. By the men, please.
Hello.
Yes, please. Are you done? Hey, some are done. Oh. You are buying pressure for my ladies. My ladies, are you there? You see, when we came here, I've not been hearing from my ladies at all. What is happening? Yes.
Your standard deviation on there, whether minus and answer question.
And the was all the best bracket on space.
7.
But can you say answer?
Yes, okay, so
No, they should wait.
They should wait. Okay. Hey, see, hey, who is that? Who is buying pressure for my ladies? Who is flexing my ladies with eyes? Who is that? Oh, okay. No, my lady is done. Oh, my lady is done. My lady, don't mind. The men are so working. Don't mind them. Okay, they are so struggling. Okay. Yes. Hey, I can hear fufu pounding in the background.
It's not fufu. It's not fufu.
Hey, with fufu in the background, if we give some answers, your wife will stop the fufu. All right, so let's see what we're gonna get here. So let's see. Let me so 1-8. So let me increase this one a little bit. Split.
We learn
So let me see is equal to square root of.
Yes. No problem.
Please, why don't we mute ourselves more?
Okay, so let's see the mean. The mean is equal to what?
20.
20, good. The mean is 20. Those of you who had decimals, okay? Good. So the mean is 20. So now we are going to use the word. So mean to subtract here. So the D. So 10 minus that here will give you minus 10. And 10 squared, 100. Here, minus what? So 11 minus that, okay, we get what? Minus 9.
Say right then.
No, the 10. I've arranged the numbers in order. So you can check your table. I have deliberately arranged it in order. 20 minus 10 minus 20.
Negative 10.
It's negative 10, right?
Yes, yes. So that one is correct.
Yes, it's correct.
Yep. And then here is what? 89.
81.
81, sorry. Then 17 minus 20 will give us
Negative
what?
10.
Negative 3. And that gives me what? 9 here.
9. Yes.
Here will give me
Negative 1.
Negative 1. And I'll get what? 1
Yeah,
here.
1. Yes.
No, negative 1 squared will give you 1.
Yes, yes, please.
Okay, so here will give you what? 28
0.
0. 0.
0.
Okay, here will give me 1. 1.
1.
And here is what? 9.
9. 81.
81. Here is
13.
18.
169.
169.
Yes.
Okay, good. So sigma this squared will give you what? You add everything. My ladies, are you
442.
there?
442.
442.
Excellent. My ladies, is that correct? Verify it for me. My ladies, are you there?
Yes,
Yeah.
sir. It's correct.
Okay.
Yes, sir.
Okay, great. So,
Yes, sir.
so in this case, the V is equal to the variance is equal to 44
Yes, sir.
442.
divided by what? 8.
8.
8.
And that will give me what?
55.25.
55.25.
0.25, right?
Yes.
Good. So 55.25. And then the next one, I want what? SD. So SD is the square root of variance. And that is giving me what? That will give me what? So that will so it will be SD will be equal to 55 point square root of this. And what is the answer?
7.43.
7.43. The lady, is it correct? Oh, okay. Angela has written 7.43 there. Excellent. Okay, good. That is so. Any headache so far? Any headache so far? Okay, good. There's another thing that they can ask you to calculate. Okay, the last thing they can ask you to calculate. Okay, so let me duplicate my slide here. Okay, great. Let me duplicate it more here. All right, great. So another thing they can ask you to calculate. Okay, let me take this one. It's called what? We call it what? We call it coefficient. Coefficient of what? Coefficient of variation. Coefficient of variation. Okay. The coefficient of variation. So let me call it maybe CV, okay, or COV. Okay, COV like that. Coefficient of variation is given by what? Is given by the standard deviation. Okay, so SD over what? Over the mean. Over the mean, let me see the mean symbol here. Mean symbol. Okay, mean symbol here. Over the mean. Over the mean. Okay, over the mean. All right. Then you multiply it by what? You multiply it by 100. We express in terms of what? Percentage. Okay. All right. So coefficient of variation, the standard, please meet your mic, is given by CV is equal to what? Mute your mic. Standard deviation over what? Over mean
times what? All times what? 100%. Okay, so we express it in what? In 100%. Okay, so like that. Percentage like this. So this one will give me coefficient of what? Coefficient of variance. Coefficient of variance is given by standard deviation divided by the mean times 100. So you express it in terms of what? Percentage. So from what we've done here, if you have to calculate the word COV, it will be given by what? What was our standard deviation? Our standard deviation was what? 7.43 divided by the mean, which is what? 20 times 100%. Okay, and what answer are you going to get?
37.15%.
So 37.15%. All right, great. Okay, good. You see that all this were all the calculation that we did. All the calculation that we did, you can see in the background there is population throughout. Good. Now let's see that we've been given the data, but this data is a sample. It's not a population. The moment they tell us that the data, so you see that all this while, everything that you are calculating, you can see the word population were in the background. No matter everything that you were doing, you can see population was in the background, right? Now, let me put something in the background that is not population. So here, the moment they say it's a sample, all right, which means that the sample means that we drew the sample from a population. When the moment they use the word sample, now this particular formula here, the moment they use the word sample, okay, they use the word sample. Okay. The moment they use the word sample, all right, sample, okay, the sample word, the moment they talk about sample variance, okay, that's one. This formula will change and you bring a word here, -1 here. So this -1 actually compensates. So last year like that, okay, last year one of the questions that I asked is that why there is what? Why n minus what? N-1 in what? In a sample variance. Why n-1 in sample variance, okay? So what it does is that we call that n-1, we call it what? That n-1 here, the -1, okay? This n-1, all right? That n-1, like that, okay? We call it what? It is called the Bessel, okay? Bessel correction. Bessel's correction. Okay, correction. And what does it? So it provide what? So what it provide unbiased estimation of the true population variance. You see, population has its own variance. Now you are going to take the data from the what? You are going to take the data, the sample from the what? From the data set. Okay, so you are going to take the what? The sample from the what? From the data, from the population. So this sample is coming from the population. So want to see that this n-2, what the n-2 does is that, okay, these are what you call the Bessel's what? Correction, all right? What it does is that it's what? It provides, okay, it provides the what? It provides a fair estimation, okay, of the what? Of the true population variance. Okay, so what is that? Is that so it provides the what? It provides the fair estimation of the what? Of the true population what? Variance. Okay, of the true population what? Variance. Okay, good. So that is what. So it provides some sort of a fair estimation of the population. Last year I gave it to them as an assignment, and I asked it in the exam. Okay, so when we are dealing with sample variance, that is where the -1 comes in. Please, do you understand that? So if I just give you the data and I didn't say sample, okay, that one you are not going to use n-1. But if I say that, oh, a sample that, please, you are going to use this one. Please, do you get the difference now? So when we say sample, you use with a -1. When I just give it to you as, oh, the total people in a class, that is not a sample. Everybody in the class was accounted for. That is not a sample. That is what? That is not a sample. Okay. All right. And so in that case, you are not going to use n-1. But please, do you get what I'm saying here? If I say the students in a class, all right. But if I say that the people were chosen randomly, okay, from something, so that one clearly it is a sample. So because that one is a sample, the moment they introduce the word sample in it, when you are doing the calculation, this n-1 must come. Please, do you get the difference? So we use this n-1 when we are dealing with what? Sample variance. But when we are dealing with population variance, we don't bring the -1. Okay, so this one, the -1 actually account for what? The fair estimate, okay, the fair estimate of the word, of the results. So let's say this one, sample, okay, great. So that's this one. Okay, great, like that. So here, what happens is that when you are dealing with a sample, you introduce -1. When you are dealing with the population, that -1 doesn't come. Okay, so it's more or less something you call like some sort of degree of freedom, okay, that you give to the data. All right, good. So when you are dealing with a sample, what sample variance, you introduce -1. Okay, when you are dealing with that's the sample variance, you introduce a -1. Okay, if you are dealing with a population, the -1 doesn't come. Okay, but when in some cases, let's take it this way, that in some cases when the population, let's say when the population is what, when the population, the sample, let's see, when the sample size is very large, okay, it's very large, the -1 is ignored. Okay, you see, if it's very large, let's say the sample size of, let's say, 1,000, this -1 wouldn't make any difference. You understand? So when the population, the sample size is very large, the -1 is neglected. Okay, the -1 is why it's negligible. Okay, when the sample size is what? Is very large, okay, the -1 is what? It's negligible. Okay, all right. Please, are we clear on that? Are we clear on that? Okay, good. So when I give you the question, okay, and let's say class, students in a class, all right, students in a class is clearly the whole class. So the whole class, there's no need to bring this -1. Everybody in the class is included. There's no need to bring -1. But if I say that, oh, people were taken randomly to form a sample, okay, it's this and this way, pick random to form a sample, that one you have to bring the -1. So when we are dealing with the sample variance, that is where the -1. So the -1 is something we call the Basel's correction. It's provide more like a fair estimation of the true population variance. Do you understand that? Okay. Remember, we took the samples from the what? We took the sample from the population, and we want the sample to adequately represent the population. So to cater for some sort of what maybe the bias or something like that, then we introduce the -1. But when the sample size is very large, you forget about the -1. Okay. For instance, if it's like 1,000, 999, and 1,000, this is negligible. Okay, so when the sample size is very large, it is what? negligible. Please, do you get what I'm saying now?
Yes. Doc, please. So it means when we are calculating for the sample variance, we are going to go by the same procedure.
Everything stays the same. The only
The
difference
same.
here is that n minus 1. The n here
All
is
right.
-1. That
All
is
right.
all.
Thank you.
Everything stays the same. Beautiful. So that is where the question that our brother asked, that he has seen blah 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 and stuff like that. Good. Everything stays the same. The only difference is n minus 1. Okay. Good. Now, okay,
Hello,
yes,
Doc, please.
Aaron, your hand is up. Let me hear from you, please.
Doc, please, you allowed us to calculate. Yeah, you gave us the coefficient of variation, but you didn't tell us what it's used to do.
The coefficient of
variation.
Oh, so when you talk of the coefficient of variation, what is actually going to do is that you see, it tells us how much of the data, like more like the variance in the data, like it is actually quantifying the extent of what? The extent of the data, like okay, like let me see, how should I put it? What is the simplest way that I'll put it? So what is just trying to tell us that it is trying to quantify that yeah, there is variance in the data, but it's just trying to quantify the how should I put it? What's the best way that I could let's see coefficient ratings, but it's just quantify the relative. Okay, so good. What it's trying to do is that it's actually comparing. Okay, let's take it this way. So let's say what is the simplest analogy that I could give. So the coefficient of the data, what is doing is that you're doing something we call relative variation. Okay, so when you talk of the relative variation, meaning that it is comparing other. Let's see. Let me see something here. Let's see. Let me draw something here later. Okay. So let's say if I have something like that here, and then let's say I have another value here, I have another value there. Let's say this is my mean. All right. Okay. So what this one does is that, okay, it actually gives some sort of word. It gives some sort of a measure of the relative dispersion of the data, like how far is this one from here? How far is this one from this? Okay, so this is the mean here. Okay, how far is this value from the mean position here? So what it does is that it's actually compares the word. It actually measures the relative variability in the data set. Let me put it that way. Okay, you understand that? It's comparing relative variability, that you are here, you are from here to the mean. Another person is from here to the mean. Another person is from here to the mean. Another person is from here to the mean. Okay, another person is from here, okay, to the mean. All right, so what it does is that it compares all that and then it quantifies it in the form of what? Percentage for us. Do you understand what I'm saying here? So it will compare all the relative variation in the data set, okay, and it's quantify all the relative variation in the data set and express it in terms of what? Percentage. Okay. Please do you get what I'm saying here? Let me put it here. Let me go to where I talked about it. Okay. Okay, great. So it's what? So it's what? It's more or less quantifies. Okay. Quantifies the relative variation in the data set. Okay, it quantifies the relative variation in the what? In the data set. Okay, basically. Okay, so relative variation in the data set. Okay, so what it means is that the higher the what? The coefficient of variation, okay, the higher the dispersion relative to the mean. Okay, so let's say the higher the coefficient of variation, okay, the higher the what? The higher the what? The higher the what? The dispersion, okay, the dispersion, okay, relative the dispersion relative to the mean. Okay, the higher the dispersion relative to the mean. Okay, and when there is high like that, when there is high dispersion relative to the mean, what it means is that the values are what? The values are quite what? Precise or consistent. Okay, so when we get it like that, it means that, okay, it means that the values, the virates are more precise. Okay, more precise, okay, or consistent. All right, good. So when we have the word, the higher the word, so the higher the coefficient of variation, okay, the word, it means that the higher the dispersion relative to the word, to the mean, okay, relative to the mean, okay. So this means that, okay, relative to the mean, okay, and then, okay, oh, I think I've turned it the other way around. Relative to the mean, okay, and then the lower the COV, okay, it means that the word, the lower the word, the lower the dispersion, okay, relative to the mean. Okay, good. Now let me use diagram to explain this one to you. I think this idea. So let's see. Now, okay, let's see. I think we are done with this one. I duplicate the slide. Did I? Okay, so let's see. Okay. Okay, good. Let me duplicate this one here. Okay, great. And then I will draw, let me draw something to illustrate what we meant by this one. So if I draw, let's see, if I draw something like this. Okay, great. So if I draw a graph like this, let's say a graph is like this. Okay, and the mean is here. This is the mean position. Okay, what it means here is that what's the coefficient of variation that is that it tells this. Okay, so let's take it how the values are spread from here. So maybe the values here, the values here, the values here like that. Okay, so when the values are spread like that, okay, so this is the mean position here. And the values are here, 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 here like this. Okay, so when it happens like that, we can say that it has what? It has high. So when there is high dispersion, it means that the values are there's high variability. When it is low, let's take it when it is low like this one. Okay, like this. Let's say the mean is here. Okay, so the mean is here and the values are all here like this. The values are all here. Okay, the values are all here. Okay, so this is what I wanted to explain. I think I had it. So here, when it is here like that, what does it mean? It means that the values are very consistent. They are very close. Have you seen it? So when the coefficient of dispersion is what? Is low. What it means that the values are consistent. Okay, so they are very close like that. And then when it is like this, when it is quite spread like that, okay, so this is the mean. Let's say this is our mean position here. This is also mean position here. Okay, mean position here. So when we have high coefficient of what? When we have high coefficient of of variation, what it means here is that the values are what? The values are what? Are quite dispersed relative to the mean. So if the mean is here, the values are quite relative to it. So some are here, some are there, some are there, some are there, like that. Okay, but when it is low, it means that the values are close. So the mean is here. If the mean is here like that, the values are very close. The values are not far. They are not far from the mean. And if the values are not far from the mean, what it means is that, what it means here is that, then it means that, so when COV, okay, is low, okay, it means that the variates are what? Are more precise. They are consistent. Okay, when it's low, when COV is low, it means they are very close. They are very close to the what? The mean. Okay, so almost all the values are very close to the mean like that. Okay, and when the values are very close to the mean, what it means here is that, okay, the words, the values are quite consistent, very precise. Okay, all right, good. So this is the mean here and the values that you had. Okay, just like the example I gave here. Okay, so here, what's the first example? The example here. So here, like if you calculate the coefficient of what COV for this one, it will be what? It will be low. Why? Because I've not. Let me see the mean of this quickly. Let me put the mean of this. Let's say mean quickly. Okay, let's see. The mean value is okay. The mean value is 20.6. Okay, so the mean value here. Okay, the mean value here is what? Is 20.6. So you can see that all the values are around this one. All the values are around. They are very close to 20, 20, 21, 20.6 is the mean position. So this is the mean. So this is the mean here. Okay, mean here like this. So the coefficient of variation is low. And when the coefficient of variation is low, it means that the values are what? The virate. Okay, the virate are consistent or precise, consistent. Okay, good. So here, like, okay, you can see that when you measure, it will be what? It will be high here. Okay, coefficient of variation will be high here. So it is measuring the what? It is measuring the relative what? It is measuring variation relative to the variation of the data set, okay, or the data point relative to the mean. Okay, so when it is high, it means that the values are widespread, okay, from the mean position. When it is low, it means that they are all clustered, okay, like that. You can see this one here, they are clustered to the mean position, like that. Okay, good. Okay, good. So our time is up, but I will do one example where I will give you the data in table form, and then you will do it, okay, without my help. And then after that one, then we can call it a day because I'm tired and hungry as well. So what I will do is that I'm going to give you a table, okay, one table, okay, that I'm not going to help you. And then you are going to go all the way to calculate for your work, calculate for your deviation, okay? And here, okay, so here, so I will say that this one is what? Let's say this one is population. So let's say this is population. I'm going to give you data set of what? Of ages of what? So ages, okay, so ages of all the children at a carnival, carnival. Okay, good. Now let's see. Okay, so let's say if I give you this, okay, table, I'm going to insert a table. Okay, do you know where? I want this. Okay, so let me go here. So I want the columns to be, okay, so let me give you 2. Okay, so I want the rows to be up to 10. So 1, 2, 3, 4, 5, 6, 7. Okay, up to 10, 11. And then let me give you this one, 2. Okay, great. Like this. Okay, good. So, okay, good. So here, children at what? At a carnival. Okay, great. So let's see something. Let's see the ages. So age here and frequency. Frequency. Okay, there are so many ways you can calculate this. Okay, I will give various formula, so it is up to you, the one that you are comfortable with. Okay, and then 2, 3, 4, 5, 6, 7, 8, 9, 10. Have I missed something? 1, 2, I've missed 3. 3. And then let's say the frequency is this. The frequency here, 14, 14, 30, let's say 32, okay, let's say 40, let's say 52 here, let's say 80 there, 80 here, let's say 80, let's say, let's give this one, let's say 59, 9, and then let's say 56, and let's say 21, and let's say 16. Okay, so let's say children's carnival. Okay, so children had a carnival. Okay, children's carnival. Okay, great, like that. And then the question goes. Okay, then I ask you a question like that. Let's say, let me duplicate. Oh no, where is my table? Is this one here? Okay, so let me bring this one. Copy this one here, and then bring it up. It's not coming. So let's see, let me look at this and then bring this one. Copy it and bring it here. Okay, great. So now the first question goes. My question is that calculate mean, B, variance, and then D, standard deviation, and then last one is coefficient of what? Coefficient of variation. Coefficient of variation. Okay, great. So let's see with this particular question on board. Okay, now you see when it is listed, it is very easy. But what about when you get something like a table form like this one? What do we do? Okay, what do we do then? Okay, great. If you get something like a table form like this, what do we do? All right. So the first thing we need to do is to calculate the word. We are going to calculate our mean. Okay, so we are going to calculate the word population mean. But this one is all the children. It's not a sample of the children. There are so many formulas you can use. It's up to you. Sometimes I will try and give various formulas because people are comfortable with other formulas that they have that maybe. Okay, great. So in this case, when we come to our formula, okay, let's go to our formula here. Okay, all right, so let's see this one. Let's bring our formula here. All right, and then let's see what we're gonna do here with our formula. Okay, good. Let's say with our formula here like this. Okay, so this is my variance formula like that. Okay, so good. So we'll get this divided by that. Okay, so which means that we can get D, our D squared, but in this case, it will be what? It will be sigma what? FD squared, and here will be what? Here will be what? Sigma what? Over sigma F. All right, so we'll get sigma FD squared over sigma F. All right, good. So when it is a variance, there will be -1 in it. If there is no variance there, we're not going to use any -1. So let's start. Okay, good. So we are going to calculate the mean. So everybody, all hand on desk. Okay, so this one, you can see that this is standard question you can get in exam. Okay, so without my help, okay, everybody, let's start. Okay, good. Let's start. Okay, calculation of the mean. Okay, great. Let's start. Okay, great.
So, this one is it under sample or population?
No, it's population. I said all the children. So I didn't bring the -1. So this one is clearly sample. Sorry, it's clearly population. I say all the children. Okay, all the children all the children at a carnival. At a carnival. Okay, so all the children at a carnival. Even if I say all the children in class, because the whole class will be population of a class. Okay, if I pick that random, oh, this and this were randomly, that is where you bring the one, -1. But all the children here, you won't bring the -1. Okay, all right, good. So here, it's up. I'll give you all the various formula in exam. This one will be there. It's up to you. The one you are comfortable with, then you do it. So let's start, okay?
Sir, that's a question, please.
Go ahead.
With this table, I beg you.
Yeah, so yes.
With table, finding the mean. I know of multiplying the age by the frequency to get the FS. Can I use that method?
That's what you are going to use. That's what you are going to use to get the mean.
Creating another column. Then after that.
So that's what I'm saying. That's how I've given it to you. I want to see what you are going to do.
Oh, okay.
So go ahead. Let's see what you are going to do.
Okay.
Okay. So let's see. Let me insert. Okay. I want to go to the next table. Okay. Okay. So let's see. So you copy this one so that I go to the next. So that I can also start working with you. And then when we are done, then it's closed. Okay. Okay. So there's various formula you can use. It's up to you. The one you're very comfortable with. Okay. The deviation method is there. If you don't want to use the deviation method, there's one too that you can use for the variance. Okay. You can use this one. Some people don't like the deviation method. They can use this one. You can use let's see, this method. It's up to you. The one you are comfortable with. Okay. So some people use this method. That is a f squared. Okay, let's stick to this method. After that, then I will go. Okay, so I'm sure you've started. So let me duplicate a slide and then let me check. Okay, this table here. Okay, and then all right, good. Okay, so let me construct another table. So here, 5 columns. Okay, like that. Okay, good. So what I could do is that here is my age, which is what X. And then here becomes my F, the frequency. And then I have something like FX here. Okay, FX here. All right. Then I have another one. So here I will do my word, my deviation. D is equal to what? D is equal to what? That is a X minus what? Minus the mean. Okay, X minus the mean. And then I'll get my D squared. Okay, the D squared. Let me go and pick it from here. Okay. Then after that, I'll get my word. This, and then d squared. Okay, then you multiply the d squared by the frequency. Split. Okay, good. And then you come here to be f d squared. Like that. Okay, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, and let's see. Let me go and copy my values here. The frequency values here. Okay, bring it here like that. So here I'm going to find my mean. So the mean is what? So the mean is, what is the mean here? So 14. This times is 60. 90, 96. Okay, 96, 160. Okay,
96, not 86.
9. This one 4 times.
That 3 times.
Yeah, it's 96. Sorry, 96. Good. This one will give me where? This one will give me 210, right? Is that not it? 210. 80 times 6 is what? 80 times 6. 480. 480. 7 times 59. Yes, what is the answer?
So the 52 times 5 is 260.
It's what?
260.
260.
Yeah, it's 260.
Yes, please.
Yeah.
Here is 260. Okay, oh sorry, 260. Yeah, you're right. Yes. And then here 7 times this. Yes, give me the answer.
413.
413. 413. 13.
413. 413.
413. Next one. 8 times 56.
448.
448.
8.
189.
189.
1 word.
89.
89.
89. And then 160.
160.
Okay, good. All right. Good. So here we want to find our mean. So let's see. Let me split this. Split this. So here sigma what? So I want my sigma f here. Okay. Let me bring my so sigma here. So this one will give me what? So here will give me sigma f. Oh no. Okay, so this one will give me sigma f. Okay, sigma f. And this one will give me sigma fx, right? So sigma f is equal to what? Yes.
400.
400. Okay, and then fx is equal to what?
2,800.
2,280.
That is it.
2,280.
Yes. The men. What are the answers? 2,000 what?
280. 2,280.
Okay, excellent. And then the deviation. So do you know deviation? Now, what is our mean? So our mean is equal to what? So the mean is equal to
5.7.
Do 5.7, damn it. I didn't want it to be decimal. Oh, okay, no problem. So it will be what? So the mean equals to what? Equals to 5.7. Okay, good.
Can we approximate?
Was it straightforward? Was it a direct value that we had?
Yes.
Yes.
Okay, direct from there. Okay, no, then let's go with it. Let's go with it. So here, so now we get 14. So what we are going to get is that 1 minus what? So here 1 minus what? 1 minus 5.7. Okay, the answer you get. So here, don't change anything. Keep everything on the calculator. What's the answer you are going to get?
Negative 4.7.
So minus 4.7, and then you square it there and there. Don't do it anything. Just square it. All the answers in the square section should be positive. So just square it quickly. When you square it, what are you going to get? So this one, you keep everything on the calculator. But here, all the answers here will be positive. So just whatever you get, you square it, you write a positive answer, you multiply it quickly.
22.09.
It's what?
22.09.
22.09 times 14. Times 14, what are you going to get? Times 14. Times 14.
309.226.
2 what?
309.
309.26. 26. Good. Let's come to this one here. What are you going to get? We'll get 2 minus what? 5.7. What are you going to get here?
Negative 3.7.
Negative 3.7. So then you square it, you get what? You get
13.69.
13.69, and you multiply it by 60. So you keep everything on the calculator. Don't change that. Like you keep everything on the calculator. Yes. Times 60.
821.4.
821.4. Good. Yes. The next one. Here, 3 minus what? So 3 minus
5.7.
5.7. It's giving us what? Yes.
Negative 2.7.
Negative 2.7. Then you square it.
You get 7.29.
7.29 times the frequency times 32.
Times
Please, the other one, you multiply it by the 60.
Hey, we should multiply by frequency.
So the other, you multiplied that one, it was multiplied by the 60.
It should be the frequency, please.
So you should correct.
Frequency, please. It's the frequency, not the 60, please. This one should be frequency. So 13 times 30 is what? 13.69 times 30.
410.7. 410.7.
0.7. Okay, good. And this one times 32 here, yes.
233.28. 233.28.
233.28. Yes. Next one. So here, let me write the answer straightforward so that we don't waste time. Okay, so here will be 4. So here will be what? 1 minus 1.7. Here will give us minus 0.7. Here will give us 0.7 or
0.3.
0.3. Sorry, good. 0.3. Here will give us what? 1.3. Here will give us 2.3. Here will give us 3.3, 4.3. Okay, 3. So we square it. Okay. Square it. Square, and then you square, and then you multiply it by the frequency, and then you give me the answer. Okay, great. Okay, so please, while some people are doing the top one, some people should do the down one so that we hurry up. So 40. So let's see. Let me also take my calculator on my phone. Okay. Okay, so we have what? 1.7 squared. Okay, it's what? 2.89, right?
2.89.
Okay, so 2.89 times what? Times 40. 40. Right? That will give me 1156. 115.6. Next one. The next one is what? 0.7 squared. 0.49. Okay, times what? Times 50.
52. Times 52.
Okay. 0.49.
Times
0.49. What's the answer? 0.49. Okay, times what? Times
52.
Times what? 50 what?
2.
Times 52. What's the answer? What is the answer? 25.
25.48.
Point what? 48. Okay, and this side is going to give us 0.09. Okay, times 80. So
7.2.
7.2. Good. 7.2. Okay, 0.2. And then here is next one. Here is what?
1.69.
1.69 times 59.
99.71.
99.7 what? 71. And then the next one is we get 2.6.
5.29.
5.29 times 56.
296.24.
296.24. Yes.
10.89.
10.89.
228.69.
228.69. The next one.
18.49.
13 for what?
18.49.
18.49. Giving us what?
295.84.
295.33. 84. All right. So please, we need a summation of this. Okay, Sam. Let me see whether I can do it quickly.
2022.
Okay, let's see. So this. Okay, so this. Okay, so you had what? When you sum everything, what are you going to get?
So I had 2022.
2022. Okay, so I've copied it here.
Same thing.
Okay, so good. That's been confirmed by my lady. Accepted. Okay. The ladies, if you let the gentleman whip you, I can't have another class with you. Boys, if they whip you, Okay, so here, this, okay, good. So this one will give me equal to what? What the answer? So 2 what?
2022.
2022.
2022.
All right. Okay, 2022. Now we are going to use our formula. So now you use this formula. Okay. So use this formula and let's see what you're gonna get.
So 2022 over 400.
So our variance is equal to what? Our variance is equal to 2000 and what? And 22 divided by what? Divided
400.
by 400. Excellent. And what is your answer?
5.055.
5.055. So this is your what? Your variance, right?
Yes, please.
This is the variance. So the variance is equal to what? 5.055. Is that not it?
Yes, sir. That's it.
Okay. What is my standard deviation now?
So that you take the square root of 5.055.
Yes,
And the answer is 2.248.
2.248. 48. Okay.
Yes, please.
Did you do any approximation or you just went straight forward?
Say approximation.
There are a lot of numbers there.
Approximation will be 2.25.
So here, what did you get this one? This one was not approximation.
No, please.
No, please.
No.
This one was not approximation.
Yes,
So 5.06.
Okay, I'm coming. Let me drag my. Oh, okay, great. So here you had what? You had 2 point what?
2.25.
2.25. Okay, so approximately 2.25, right?
Yes.
Okay, 2.25. All right, good. And then, okay, what is the coefficient of variation?
39.47.
So coefficient of variation. Usually, I don't give that formula in exam. Last year, I didn't give them that formula. I didn't give them for coefficient of variation. I didn't give it. Okay, I gave the other one. So here, remember it is where it is COV is equal to what? It's equal to the standard deviation over the mean. The mean times what? 100. Okay, and what's the answer are you going to get?
39.
So the answer is going to be what? 39.47%.
47%.
So 39.47. So what? 3.47.
It's 39.
Oh, 39. 39.47%.
47%.
Okay, good. Well done.
But I think you're supposed to use all the numbers, right?
The which one?
The numbers that you got for the standard deviation.
Okay, so the standard deviation we had what? We had
2.25.
2.2.
So you're supposed to use
No, we had
2.24833 something for the coefficient of
and then
variation.
we approximated it, right?
Yeah. So I think we use the real number instead of the approximated number.
Oh, yes. We use the real number. At least the 3 decimal place number.
Yeah, so that one we're going to get 3.44.
Yeah, 39.44.
39.44.
When you use this one.
Yes.
Okay. So
Yes,
you get
please.
what? 39. So you get let's see. Let me write this. So you get 2.248 divided by 5.7. times what? Times
100.
100. And you are going to get what?
39.44%.
How come that value is higher? When we
No,
use this,
it's lower rather.
It's lower.
it should be lower. You said come again.
39.44.
39.44 to 39.44. 44%. All right. I think you guys.
So it's 39. It's made it 38.
The brain is tired. Okay, good. I think you've done very well. Okay, we've all done very well. Exactly for drop the dots. Let me save this one.
All right, Doc, please, I have a question.
Yes, please go ahead. Okay, so
Sir, please, with the coefficient of variation, can you ask us the what is the importance of that coefficient of variation as to whether the higher the coefficient variation,
okay,
the higher the dispersion relative to the mean.
Relative to the mean. Excellent.
Yes.
Excellent. Excellent.
Can you ask a question like that?
I can ask a question like that. Yes. Why not? Why can't I?
All right.
I can. Okay, but I'll make it in a very nice way, so you'll be fine. Don't worry, you'll be fine.
All right, sir.
Okay, I will. The concept is not to punish you. I mean, I don't set the exam question to punish people. The question is to see. Okay, then what is there is to ensure that you understand what I'm saying? You get what I'm saying here? It's to find out whether you understand the concept. So it's not like you want to know some. Okay, no, I want to. That's why I give the formula, but I don't expect you to memorize the formula that much. Okay, so that's why I give the formula, because I want to see did you understand what I taught? Okay, so basically that is all.
You know the age, the brains are like total mind.
Okay, so here like that, and then okay, so this one. Okay, so that in case so in what? Let me put here 5.055. I hope you just added everything straightforward. Or you approximated something. Let me check that my summation online and see. Let me check that summation online.
So straightforward.
It's straightforward. You added everything straightforward. That's fine.
Yes,
okay, great. All right. I think you've done very well.
Hello, Doc.
Okay, great. So maybe 1 2 questions and we are done.
Hello.
Yes, please.
So it means that if you want to find a variance, when the question is given the table form, that is why we use this formula, sigma f d square over sigma f.
Yes.
That's what the question is giving. The data is given a table form.
In a table form, okay. But when it's given singly, you use the when it is given singly, you use this one. Okay, you know, once it is in table form, sigma, fx, and stuff like that will come in. Okay, all right. So when they do the question in table form, this is what you do. I mean, this what I've given here is quite a tough one. Okay, if I'm bringing something like that in exam, I don't think I'll bring a table with 10 variates like that. Okay. Time.
This one
okay. So maybe in exam, if I'm bringing exam with 10 like that, then it will be more of histogram or relative frequency. Okay.
Okay.
All right. So good. But if I want you to do standard deviation with table, I think I might as well limit it up to maybe 5 like this. Okay, rather than going all the way down. Okay.
Okay.
So that is that. So I'll keep everything on this one. So let me even the mean here. Let me copy the word. So sigma word. So let me bring the sigma fx over sigma f. So that the mean. Okay, so let me bring this one here. Okay, so that okay, let me bring this one here so that people okay, so that folks will be able to understand it. So the mean was this one here. So let me quickly mean. Okay, mean. So mean is equal to sigma what? Sigma so sigma fx
So, Doc, please, the deviation squared, no need to sum that one.
Which one?
I mean, the deviation, where we squared the deviation.
Yes, we squared the deviation here, we squared it here, and then you sum everything. That's, you summed it. That's what the
Yeah,
sigma is.
we sum it like with the frequency, but it's alone. No, there's no need to sum that one.
Yes, no. If it's just singly with a table, that's where you do that. But if it's just singly, okay, I will give the evening days. I'll give the two formula. Okay, I'll give all the two formulas. So that, okay.
Okay, thank you, sir.
As I've told you, you knowing which one to use means that you know. You understand that? If you don't know which one to use, it means you don't know. Okay, so fx over y over sigma f. Okay, so here like that. So this one gave us what? It gave us 5. We did what? That gave us that gave us 2a0 divided by 400. Okay, and that gave us 5.7. Okay. All right. So this is how far the Lord has brought us. Okay. All right. So this is that. Okay. Great.
Doc, please, the slides.
Yes, I'm going to send it now. That's why I've tidied up this thing so that when you pick it, you don't get confused. Okay. So this is for sample mean. Okay. So which means that we need to meet one more, and you are done. So and then we are done with this one. So that will be next week Sunday, right? Oh?
Yeah, so yes, we can meet on next week Sunday. Yeah.
Next week Sunday we are done.
Although it's for practicals, but we can meet.
But the practical people, but what is some people go for practical on Sunday? Let me know, please.
No, sir.
Okay, so okay, good. Then we can use it for this one, and then I'll walk with you through what we did. But the trial questions that I've sent you, please make sure you go through all of them. So when we meet, God willing, on this thing next week, we'll do. Okay. So let's see topics we plan to do. So here we will do. So next week when we meet, we will do what? We will do the cumulative frequency. So we'll do one with a sample. Okay, we'll do something called standard. We'll do standard error. But standard error, you use it when you are doing for what? When you are dealing with sample. Okay. And then I will do standard error calculation, and after that we'll do the cumulative frequency. Those are ranges. Okay, those are interquarter, quarter, and then semi-quarter. So please make sure you get your graph books ready. Quarter in what? Cumulative frequency. And then we'll do the last thing we'll do is something small on t-test. Okay, t-test. Okay, that is so. Then we are done. Okay, this one should let us finish everything. Okay, good. Thank you very much, and have a good evening, and God bless you. Okay,
Yes, sir. God bless you, sir.
Okay, so Nima 2 and her colleagues, please. I'm going to send it to you right now. These ones right now. Okay, and then I will try and then WhatsApp you some questions as well, so that you can around with it. Okay.
Okay, Doc. Thank you very much.
So it is loading, so I will do that. Thank you. Great. But my people, we have to try and make time and finish the genetics. So,
No, please, you said next week.
Okay, next week. All right, that's fine. So we'll fix time. So please be on the alert. The genetics, the reason I can see that I take my time to go so much detail is that SS teachers, they don't teach genetics very well. Most of them don't teach it well. Sometimes they don't even touch it at all. But I don't want you to go. I don't want you to go to SS and go and do that. That one I won't forgive you. So please, I want you to go to your SS class, and then you teach without book. Okay, you kill the genetics, and the children will be there. It's like, yes, this is the UCC. This UCC man that came. He's something else. Yeah. So that's why I'm taking my time. But we'll finish it, God willing, and then before your exam. Okay. All right. Good.
Okay, sir.
Thank you very much for having me, and then please do have fun and take care.
Okay.
Thank you very much, Doc.
Oh.